हेलो हेलो। खुद को ही देख रहे हैं, खुद ही बोल के हेलो हेलो हेलो। ठीक है सर, आवाज तो आ गई है।
Thank you. Okay, so am I audible now? Can you hear me now? Okay, great. So yesterday I started with engineering mechanics as a subject and topic. You know, I will cover. Yesterday there was an abrupt breakdown of this lighting system, and I was to discontinue my class. So a small topic, rolling friction. There's a small topic, rolling friction, from which I'm expecting question this year. So rolling friction is a small topic which I will cover again. And as I told you, I will be covering this entire engineering mechanics in couple of lectures. So you keep enjoying the lectures, you keep learning. And in my opinion, I think a 4 to 6 marks question will come from these lectures for sure. So keep learning, and you should develop the confidence in that. So yesterday I was talking about truss free body diagram in the first video, truss free body diagram, and these small topics were covered yesterday. And now today I'm going to discuss with you the topic of rotational and angular motion. Yesterday, yes, friction was also done. So friction, truss, and free body diagram, these were the topics I covered yesterday and in the first part. And now I'm going to talk today rotational angular motion. And then if time permits, which I don't think we will have sufficient time today in next 2 hours, but then I will go for collision, springs, energy kind of topics, right, in the third video. So let me go for today this rotational and circular motion. You know, normally questions come from rotational motion, rolling motion, circular motion. Terms look like same, you know, rotational motion, circular motion, rolling motion. And there's a term related to this which is called instantaneous center, and concept of moment of inertia also comes into that. And hence kinetic energy, rotational kinetic energy is a concept which from where questions normally are asked. So first, as I told you, first I'll give you the theory part. I'll give you the theory part of all these topics which I just now I told you, and then we can go for numerical. So enjoy the theory. I'll give you the notes of all this. So you enjoy the theory, and then we go next for that. So first of all, I'll discuss with you something which is called analogy table. You know, there is a table called analogy table in linear motion and rotational motion. So if I give you linear motion and if I give you rotational motion, there is a kind of analogy between the two. Rotational motion and linear motion have analogy, and relation between the two we should understand. So if you ask me from where this rotational and linear motion and rotational motion का जो link है वो कहाँ से बनता है, let me tell you. If I give you that x is the displacement, linear motion mein x is a displacement, then I will say theta is the angular displacement which is measured in radian, and this is the link between the two. X distance is traveled and theta is the angular displacement, and x is equal to r theta. So this is the basically link between linear motion and rotational motion. So linear displacement in meter, rotational displacement in radian, and x is equal to r theta. That is the link between the two. Then you keep on proceeding forward. They will say velocity is rate of change of displacement, and hence omega, angular velocity, is rate of change of angular displacement. And hence if you differentiate both sides, v is equal to r omega. Very simple. So if there is an angular velocity somewhere, like your fan is having angular motion, so then you can find out the velocity, and that is a tangential velocity. That is a peripheral velocity. V is equal to r omega. Remember, because in the rolling motion, we are going to talk about this tangential velocity. Then we talk about the acceleration, and acceleration is nothing but rate of change of velocity. That is called acceleration, and it can also be written as d square x over dt square. Similarly, alpha is d omega over dt, and it can be written as double differentiation of theta, and a is equal to r alpha. So these two are very, very important formulas. V is equal to r omega and a is equal to r alpha. Many questions have this particular concept. I will discuss with you later on. So V is equal to r omega, a is equal to r alpha. This V and a are peripheral or tangential velocities and acceleration. So if there is a component which is basically rotating, then that component at particular moment may be having tangential velocity or acceleration also. That is how we calculate it. Now remember one important point here. I can make some manipulation here into this formula. I can write this formula as dv over dt into dx over dx. Can't I write it like this? dv over dt into dx over dx. I can write it like this also. Now I can use this dx over dt to write as v. So it can be written as v dv over dx. So acceleration can also be written as v dv over dx. When will this formula be used? If velocity is given as function of x, if velocity is given as function of x, then you can differentiate velocity with respect to x and directly calculate the acceleration. Can you give me the same formula here? Alpha is equal to omega d omega over d theta. So alpha is equal to omega into d omega over d theta. That is also one of the formulas. I can use it. Now let's go for next analogy thing. Now I talk about mass, and here I talk about moment of inertia, and what is the relation between the two? Mass and moment of inertia relation is I is equal to mk square. Now this k is the radius of gyration, and I is basically the moment of inertia. The mass is the measurement of inertia for linear motion, and moment of inertia is the measure of inertia for rotational motion. How these two are related? So there is something which is called momentum. There is something which is called momentum. So here we have linear momentum, mass into velocity. Here we have angular momentum, I into omega, and this L is equal to radius into linear momentum. So what is the relation between angular momentum and linear momentum? Angular momentum is radius into linear momentum. Great. Now there is something which is called second law. When you talk about a force which is equal to rate of change of linear momentum, or it is m dv over dt, or it is m into acceleration. So whatever role force plays, the role is played here by torque. Torque is dl over dt. That can further be written as I into alpha. And what is the relation between torque and force? Again, torque is radius into force. So rate of change of angular momentum is equal to torque. So one thing, like if suppose the linear momentum is force, there is no external force is applied, linear momentum is conserved. That is used in collision. Remember again this, if there is no external force applied, dp by dt is equal to 0 and p becomes constant. Where do you see that? We see that in the collision, because collision mein two bodies collide against one another, no external force is applied, and hence the linear momentum is conserved in collision always, whether it is elastic collision or it is inelastic collision. Now similarly, if there is no torque applied from outside, then the angular momentum should be conserved. On the basis of this concept, many questions are asked. Let me tell you again. If I say force is equal to 0, then P is equal to constant. What is the meaning of that? Sir, M1 V1 is equal to M2 V2. This concept is many places used, something like collision. If I go here, if T is equal to 0, then what happens is L is equal to constant. That means I1 omega 1 is equal to I2 omega 2. There is a table which is rotating and a small fly sits on that table, so that torque is not changed. Then I1 omega 1 is equal to I2 omega 2. Because small fly of particular mass sits on the table, moment of inertia gets changed, and hence omega also gets changed. So I1 omega 1 is equal to I2 omega 2. That question also very frequently is asked. So conservation of angular momentum, conservation of linear momentum. Next we come to power. Power is calculated as force into velocity, and here power can be calculated as torque into omega, and omega is written as 2 pi n by 60, so it can be written as 2 pi nt by 60. So if you have a body whose rpm is given to you, if you are given torque, then you can calculate the power also. This is how it is to be calculated. So linear motion, angular motion, there is some kind of relation here. Now let me tell you about kinetic energy. When we talk about kinetic energy, then kinetic energy has formula of half of mv square for linear case and half of I omega square for rotational case. So if the body is having purely rotational motion, then the kinetic energy is half of I omega square. But you know what? Majority of the bodies have rotational motion also and translation motion also. Something like in rolling motion. So if the body is rolling, I will discuss rolling point also with you. If the body is rolling, then the kinetic energy will be sum total of linear motion, I mean linear kinetic energy, translation kinetic energy, and rotational kinetic energy. So what will be the total kinetic energy? This will be half of mv square plus half of I omega square. The question from this concept has also been asked many times in the exam. Roller, we will discuss about that also. Now last topic which is of importance in analogy is uniformly accelerated motion. You know what is uniformly accelerated motion? Uniformly accelerated motion is that motion in which a remains constant. A remains constant. And in the school days, you have studied the equation of motion for a uniformly accelerated motion. What are those equations? X or S is equal to ut plus half of at square. U is the initial velocity, a is the uniform acceleration, a is constant, x is the displacement. V is equal to u plus at, then v square minus u square is equal to 2ax. So these are the three equations which are called uniformly accelerated motion equations. And then we come to this side. Theta is equal to omega naught t plus half of alpha t square. Then comes omega is equal to omega naught plus alpha into t. Then comes omega square minus omega naught square is equal to 2 into alpha into theta. So see these two equations set up. This is for linear motion. This is for rotational motion. Initial angular velocity omega naught, final angular velocity omega, alpha is the angular acceleration which is constant, and theta is the angular displacement. So if there's a tire which is basically rotating and it is at rotating at particular alpha, then what will be the total number of rotations it completes in particular time. So this is the first starting of our rotational motion. So three important places from where questions are asked. One is this particular part from where questions are asked, another is this part from where questions are asked, and third is conservation of angular momentum I1 omega 1 is equal to I2 omega 2. So let me go back and revise this small part again for you. I started with the analogy table. I told you that linear motion and rotational motion में एक analogy है. पहले तो ये equations याद रखना, v is equal to r omega and a is equal to r alpha. And I told you again clearly, majority of things will look like simple, but the kind of question which is framed is a very ticklish point वहां से उठाता है और question आपसे पूछता है. So my advice to you is that you please attend all the lectures if you really want to score 4 to 6 marks in engineering mechanics, which is easy marks for us, right? So v is equal to r omega, a is equal to r alpha, and I am expecting question in which he will give you velocity as a function of displacement and ask you to calculate acceleration. Then we talked about some another terms like how force and how torque is to be related. Linear momentum and angular momentum are to be basically compared, and then power, how it is to be calculated. And from this conservation of angular momentum question can be asked. And where do we conserve the linear momentum? Answer is in the chapter of collision. In the chapter of collision, we conserve the linear momentum. As I told you, you are not to write anything, you are to only basically understand here, and I'm going to give you on your WhatsApp group all these notes I'm going to provide you. Don't worry about that. तो कहां से क्वेश्चन आएगा यार? इस पार्ट में से कहां से क्वेश्चन आएगा? एक तो क्वेश्चन तुम्हारा आ सकता है, ये तो यूज होते हैं, डायरेक्ट क्वेश्चन नहीं आता, ये टर्म्स यूज होती हैं. एक क्वेश्चन यहां से बनता है, आई चेंज हो गया, ओमेगा कैलकुलेट करो. एक क्वेश्चन यहां से बनता है, वो आपका काइनेटिक एनर्जी निकालने को बोलेगा, और एक क्वेश्चन यहां से बनता है कि आपका इन टर्म्स को यूज करो और एंगुलर मोशन को एनालिसिस करो। तो सो फार 3 जगह से यहां से आपका क्वेश्चन बनता है, राइट? दिस इज द एनालॉजी टेबल ऑफ द टू. Okay, now let's go to define something which is called uniform non-uniform circular motion. इसको देखना, एक क्वेश्चन यहां से बनता है, यूनिफॉर्म सर्कुलर मोशन, and second is what? Non-uniform circular motion. Non-uniform, do you know what is the meaning of uniform circular motion? भाई जब मैंने बोल दिया यूनिफॉर्म सर्कुलर मोशन, तो यूनिफॉर्म का मतलब होता है कांस्टेंट, सर्कुलर मोशन, मोशन का मतलब होता है वेलोसिटी. थिंक ऑफ दिस, यूनिफॉर्म मींस कांस्टेंट एंड मोशन मींस वेलोसिटी. Let me tell you, uniform circular motion means what? This means that if I give you different points A, B, C, and the body is having, let's say there is a circular motion of radius R. Just now what we said? Velocity, velocity, velocity. Just now what we said? We said that V is equal to R omega. Omega क्या है? Angular velocity. R क्या है? Radius. And V क्या है? Tangential velocity. You know, in this case, as you can see, different positions के ऊपर A, B, C के ऊपर velocity का magnitude is same, direction same नहीं है, magnitude is same. Why? Because omega is constant. अगर constant angular velocity के साथ rotate कर रहा है, uniform constant, circular omega motion, omega constant के साथ ये rotate कर रहा है. So R is constant, omega is constant, V is also constant. लेकिन याद रहे v is equal to constant only in magnitude, not in direction, but velocity is vector. So if velocity is a vector, rate of change of velocity is also changing. That means acceleration is there. Hence this is velocity as a magnitude is constant, but uniform circular motion has acceleration. And let me tell you that acceleration which is because of change in direction is called centripetal और रेडियल एक्सेलेरेशन. कौन से फॉर्मूला से निकालते हैं उसको निकालते हैं v स्क्वायर बाई आर या आर ओमेगा स्क्वायर फॉर्मूला से निकालते हैं. बहुत इंपॉर्टेंट कंसेप्ट है, याद रख लेना इसको ध्यान से. सो दोबारा सुनो, इफ द बॉडी इज हैविंग कांस्टेंट मैग्नीट्यूड ऑफ वेलोसिटी, राउंड अबाउट पे घूम रहे हो तुम, वेलोसिटी का मैग्नीट्यूड इज कांस्टेंट, बट यू नो व्हाट, यू आर चेंजिंग योर डायरेक्शन कंटिन्यूअसली. सो इफ यू आर चेंजिंग योर डायरेक्शन कंटिन्यूअसली, then it's a case of your acceleration. So the acceleration which exists because of change in direction of velocity is called centripetal acceleration or radial acceleration. How do you calculate that? V square by R or R omega square. V की वैल्यू वो आपको दे देगा. Now what is non-uniform circular motion then? Okay, non-uniform circular motion means when I calculate velocity at A, velocity at B, velocity at C, then you know what? The magnitude as well as direction changes. Non-uniform means it is changing. That means omega is not constant. Yes, alpha is constant. I can assume that alpha is constant. And if there is alpha, angular acceleration, omega cannot be constant. That means omega constant नहीं है. और अगर omega constant नहीं है तो velocity भी constant नहीं है. So at particular position, if I want to find out, at particular position, if I want to find out acceleration now, there will be two accelerations which will be coming in picture. One is tangential acceleration. How do you calculate tangential acceleration? R into alpha. अभी तो निकाला था कि अगर alpha हमें दिया है तो tangential acceleration कैसे निकालते हैं? R alpha. And second acceleration, obviously direction is changing. That is centripetal acceleration. What is that? V square by R or R omega square. तो अगर उसने आपको R ओमेगा स्क्वायर, उसने आपको ओमेगा भी दे रखा है, अल्फा भी दे रखा है, he will give you omega also, he will give you alpha also. Omega is not constant, but at particular position omega की value can be there. So omega is there, alpha is there. Hence we have R omega square, that is centripetal acceleration, and R alpha tangential acceleration. When we have these two, then from these two what we can calculate is, we can calculate total acceleration as centripetal acceleration plus the tangential acceleration, centripetal acceleration plus tangential acceleration under root, square of this under root. So what is the total acceleration? Total acceleration is the basically vector summation of tangential acceleration and centripetal acceleration. So AT square plus AC square under root, that becomes our टोटल एक्सेलरेशन। एंड बिलीव मी, इस कंसेप्ट से बहुत बार क्वेश्चन पूछा है कि एक्सेलरेशन बताओ इफ देयर इज अ acceleration of the body when it is moving on a roundabout, and there is a basically change, roundabout is there, so change in direction is also there. So use these two formula, r alpha and r omega square. Alpha and omega will be given to us, and we can calculate total acceleration. This is uniformly circular motion. That is number one, you have to understand. So that is also important part from where question comes. Okay, now rotational motion analogy we have seen the uniform, non-uniform, circular motion also. And now I come to very important topic, next topic, which is called your rolling motion. So what is the meaning of rolling motion? Let me tell you that also. What is the meaning of rolling motion? Which body is said to be rolling? You see this now. I can divide rolling motion into two parts, and let me divide that into two parts. Let's say A, let's say B, let's say C, let's say center as O, let's say D. This entire body is moving forward with velocity v. Let's say there is a body और वो सारी की सारी आगे v velocity से चल रही है. उसको क्या बोलते हैं? प्योर ट्रांसलेशन बोलते हैं. उसको बोलते हैं प्योरली ट्रांसलेशनल मोशन एंड ट्रांसलेशनल वेलोसिटी को मैंने बोल दिया v is the translational velocity. समथिंग लाइक कार मूविंग ऑन हाईवे, तो उसके हर पार्ट का वेलोसिटी सेम है. इस ट्रांसलेशन मोशन को अगर मैं प्योरली रोटेशनल मोशन के साथ जोड़ दूं, प्योरली रोटेशनल मोशन के साथ जोड़ दूं, और अगर ओनली प्योरली रोटेशनल मोशन हो रहा है, तो दिस इज द साइन फॉर दैट. दिस इज द साइन ऑफ ट्रांसलेशन, दिस इज द साइन ऑफ रोटेशन. नाउ ए पॉइंट के ऊपर वेलोसिटी, लेट्स से VA, VB, VC, VD, एंड यू नो व्हाट, द वेलोसिटी एट ऑल दीज पॉइंट्स एज वी नो, अगर ये ओमेगा वेलोसिटी के साथ रोटेट होता है, इफ इट इज रोटेटिंग विद वेलोसिटी ओमेगा, कैन यू टेल मी व्हाट इज VA? Yes, VA is R omega. What is VB? That is also R omega. That is VC, R omega. What is VD? R omega. And what is the velocity at the center? R is 0, and hence यहाँ पे velocity 0 है. इसको बोलते हैं रोटेशनल मोशन. इसको क्या बोलते हैं? रोटेशनल मोशन. एंड हर जगह पे पेरिफेरल वेलोसिटी या ट्रांस आपकी टेंजेंशियल वेलोसिटी कितनी है? टेंजेंशियल वेलोसिटी इज R omega. Yes, you take any point on tangent and you will find that the velocity is R omega. Now, when you add these two, what we get is a rolling motion. So what is a rolling motion? Somebody ask you, sir, rolling motion is nothing but, rolling motion is the sum of translation and rotation. How is this shown? Sir, this is shown with this particular sign, velocity and omega. So if there's a body which is translating with velocity v and it has angular velocity of omega, this is a sign of rolling motion. This is a sign of translation, this is a sign of rotation, this is a sign of rolling. Translation also, rotation also. Now, what kind of velocity I can expect at point A? Sir, at point A there is a R omega also, and at the point A there is a velocity also, that is the translation velocity. Both are same. This velocity is translation, this velocity is पेरिफेरल वेलोसिटी. डन. यहां पे क्या है? सर यहां पे ट्रांसलेशन वेलोसिटी ये है और पेरिफेरल ये है. इस जगह पे क्या है? सर यहां पे पेरिफेरल वेलोसिटी R ओमेगा है और ट्रांसलेशन क्या है? वो V है. यहां पे क्या है? सर यहां पे R ओमेगा ऐसा है और ट्रांसलेशन ऐसा है. This is, we have written velocities at all the places. We have written velocities at all the places, right? Now see most important thing. If this point is point of contact, if this point is point of कॉन्टैक्ट, अगर मैं इसको पॉइंट ऑफ कॉन्टैक्ट ले लूं रोलर बॉडी का, पॉइंट ऑफ कॉन्टैक्ट एट सरफेस, लेट अस से दिस रोलिंग बॉडी, दिस इज अ रोलर और ये एक बॉडी रोल कर रही है किसी सरफेस के ऊपर, एंड दिस वन इज द पॉइंट ऑफ कॉन्टैक्ट. You know, there is something which is called no slip condition, no skidding condition, no skidding, no relative motion between this point and the surface below it. And if we take no skid, no slip condition, तो इस जगह पे आपकी वेलोसिटी c पे 0 होनी चाहिए. और अगर c पे वेलोसिटी 0 होनी है तो क्या होगा? These two velocities are to be same, that v is equal to r omega. Do not think that this v is that peripheral velocity जो हमने फॉर्मूला बनाया है. पेरिफेरल वेलोसिटी तो हमने लिख ही दिया है r ओमेगा सब जगह, लेकिन ये वो v है जो बेसिकली आपका ट्रांसलेशन वेलोसिटी है. एंड इफ देयर इज अ रोलिंग बॉडी on the surface, it is having translation motion v, and omega is the angular motion and r is the radius. Remember one thing, for no skid condition v should be equal to r omega. Now what is the meaning of that? That means sir ये जो v है और r omega सेम है, तो यहाँ पे velocity total कितनी हो गई? ये तो 2v हो गई. अच्छा यहाँ पे कितनी हो गई? v and this is also v. ये रूट 2v हो गया. और यहाँ पे कितना हो गया? अगेन रूट 2v हो गया. और यहाँ पे कितना हो गया? 0 हो गया. और सेंटर पे कितना हो गया? v हो गया. इस कंसेप्ट से बहुत बार क्वेश्चन पूछा गया है अलग अलग तरीके से. सो यू अंडरस्टैंड, रोलिंग बॉडी इज द बॉडी which translates also, which rotates also, and hence on rolling body he will take any point at which he will ask you to calculate the total velocity, and total velocity will be translation velocity plus that will be the आपका पेरिफेरल वेलोसिटी. उन दोनों को आपको ऐड करना पड़ेगा वेक्टर अलजेब्रा. एंड रिमेंबर नो स्किड कंडीशन दैट ट्रांसलेशन वेलोसिटी विल बी इक्वल टू इस पॉइंट के ऊपर जो आपकी पेरिफेरल वेलोसिटी है, तो v इज इक्वल टू r ओमेगा. डन. अब ये जो चीज तुमने वेलोसिटी के लिए किया, सेम चीज एक्सेलरेशन के लिए किया जा सकता है. ओनली डिफरेंस विल बी इफ आई मेक सम काइंड ऑफ एनालिसिस हियर, v will be replaced by a and omega will be replaced by alpha, and hence we will say that a is equal to r alpha. And you know what, यहां पे acceleration 0 होगा. Why? Because if velocity is 0, acceleration is 0. Remember again, there is a rolling body and it is rolling at particular acceleration. मतलब उसकी acceleration a है और उसकी angular acceleration alpha है. So मैंने आपको एक roller दे दिया. It is not moving with a particular constant velocity omega. It is moving with particular constant acceleration alpha. So rolling body is moving at particular acceleration alpha and it is having linear acceleration, translation acceleration a. Now find out the acceleration at particular point of the body. That is what he is going to ask you and you have to calculate it. Typical कैसे क्वेश्चन बनते हैं, मैं तुम्हें एक क्वेश्चन फ्रेम करके देता हूं. अगर मैं तुम्हें एक रोलर बॉडी दे रहा हूं, मैं तुम्हें बस इतना दूंगा कि ये इसका ओमेगा है और ये इसका वेलोसिटी है और इसका रेडियस है. भाई मेरे को इस पॉइंट ए के ऊपर वेलोसिटी बता दो, कितनी वेलोसिटी होगी, इस पॉइंट पे कितनी वेलोसिटी होगी. अरे यार इस पॉइंट पे v वेलोसिटी तो ट्रांसलेशन होगी और इसी पॉइंट पे जो पेरिफेरल वेलोसिटी होगी वो भी v होगी, राइट. एंड इफ यू नो दिस पर्टिकुलर एंगल थीटा, देन यू नो यू कैन यूज द वेक्टर अलजेब्रा. व्हाट इज वेक्टर अलजेब्रा? सर ये है वेक्टर अलजेब्रा. दैट इफ आई गिव यू टू वेक्टर्स a एंड b और उनके बीच में अगर एंगल थीटा है तो रिजल्टेंट कैसे निकालते हैं? रिजल्टेंट निकालते हैं सर a स्क्वायर प्लस b स्क्वायर प्लस 2ab cos ऑफ थीटा अंडर रूट. ये मेरे पास मैग्नीट्यूड निकल जाता है उसका वेलोसिटी का. तो अगर मेरे को किसी रोलर बॉडी के किसी पॉइंट के ऊपर तुम मेरे को बोलो कि वहां पे वेलोसिटी निकालो, तो ऑल यू हैव टू डू इज यू हैव टू फाइंड आउट द ट्रांसलेशन वेलोसिटी व्हिच एवरीवेयर इज सेम एंड यू हैव टू कैलकुलेट द पेरिफेरल वेलोसिटी व्हिच डिपेंड्स अपॉन रेडियस. फॉर एग्जांपल अगर मैं तुम्हें पॉइंट यहां पे दे दूंगा, let's say this is at r by 2 distance, can you tell me what is the peripheral velocity and what is the translational velocity? Yes, translational velocity is v, peripheral velocity is r by 2 omega, and because v is equal to r omega, तो यहां पे टोटल वेलोसिटी कितनी हो जाएगी? v plus v by 2, 3v by 2 आपकी टोटल वेलोसिटी हो जाएगी. तो इस कंसेप्ट से वो बहुत क्वेश्चन पूछ चुका है और मेरे को लगता है अब वो एक्सेलरेशन का कंसेप्ट पूछेगा कि एक्सेलरेशन कितनी होगी. तो लेट मी नाउ आस्क यू, इफ आई गिव यू अ रोलर बॉडी, रोलिंग बॉडी, पॉइंट ऑफ कांटेक्ट पे वेलोसिटी कितना होता है? नो स्लिप कंडीशन के लिए 0. एक्सेलरेशन कितना होता है? 0. पॉइंट ऑफ कांटेक्ट पे दोनों 0 होगा. एंड कैन यू कैलकुलेट वेलोसिटी और एक्सेलरेशन एट एनी पॉइंट, at any point on that particular body? Yes, we can calculate. और एग्जाम में वो ऐसा क्वेश्चन फ्रेम कर भी चुका है और ऐसा क्वेश्चन और फ्रेम करेगा भी. सो रोलर बॉडी का ये कंसेप्ट हमारा वेलोसिटी वाला इज समथिंग विच वी शुड नो. अब मैं रोलर बॉडी के ऊपर ही एक और कंसेप्ट पे आता हूं जहां से क्वेश्चन आते हैं. एंड लेट मी टेल यू, जब मैं इसको खत्म करूंगा अभी आफ्टर सम टाइम, आई थिंक 20-25 मिनट में, 15-20 मिनट में, तो मैं आपको सारे पॉइंट्स बता दूंगा जहां से एंगुलर रोटेशन, सर्कुलर मोशन से क्वेश्चन आते हैं. और यही सबसे ड्रेडेड पार्ट है पूरी इंजीनियरिंग मैकेनिक्स का. स्टूडेंट्स को विजुअलाइज करने में ट्रबल होता है. सो वी विल अंडरस्टैंड दैट. अब यहां से एक क्वेश्चन आता है, काइनेटिक एनर्जी ऑफ रोलिंग बॉडी. आई टोल्ड यू वन थिंग, रोलिंग बॉडी इज ट्रांसलेटिंग ऑल्सो एंड रोटेटिंग ऑल्सो. तो भाई काइनेटिक एनर्जी दो तरीके का होगा. एक सर ट्रांसलेशन काइनेटिक एनर्जी प्लस दूसरा रोटेशनल काइनेटिक एनर्जी. ट्रांसलेशन काइनेटिक एनर्जी कैसे निकालते हैं? हाफ ऑफ mv स्क्वायर. और रोटेशनल काइनेटिक एनर्जी कैसे निकालते हैं? हाफ ऑफ आई ओमेगा स्क्वायर. लेकिन मेरे को टोटल निकालनी है यार, मेरे को इनको टोटल को ऐड करना है. मेरे को टोटल काइनेटिक एनर्जी चाहिए, बिकॉज कंजर्वेशन ऑफ एनर्जी में मेरे को इसको पोटेंशियल एनर्जी के साथ कंपेयर करना है, तो मैं कैसे निकालूंगा? नाउ सी वन थिंग, we need to know the concept of movement of inertia, and because we are dealing with three dimensional bodies, we are not dealing with the plane, we are not dealing with two dimensional bodies, we are dealing with three dimensional bodies which have mass, and we are talking about the energy. तो मेरे को mass movement of inertia लेना पड़ेगा, जो basically I होता है mk square, k is the radius of gyration. Now should I give you moment of inertia of certain bodies, which we should know moment of inertia of certain bodies, and कौन कौन सी bodies का moment of inertia आपको याद रखना है? एक, अगर मैं आपको एक रॉड दे दूं जिसका मास और लेंथ हमें दे रखा है m and l, तो उस रॉड का moment of inertia about centroid is ml square by 12, and about one of the axis is ml square by 3. About the centroid is ml square by 12, and about the axis is ml square by 3. You know that moment of inertia depends upon axis of rotation. तो ये रॉड दे दी, अगर ऐसे को रोटेट कर रही है एक्सिस पे, अभी ये रॉड एक्सिस पे रोटेट कर रही है, इसका एग्जांपल क्या है भाई? लैडर. लैडर जानते हो ना तुम, सीढ़ी, लैडर, उसका मास भी दे रखा है, उसकी लेंथ भी दे रखी है, और लैडर स्किड कर रही है, तो आप उस लैडर को एक सेक्शन पे उसका निकाल सकते हो. सिमिलरली देयर इज अ रॉड व्हिच इज बेसिकली सपोर्टेड लाइक बीम, तो उसके लिए भी आपको इसको निकालना पड़ेगा. सो ये आपका फॉर्मूला वहां यूज होता है. अब दूसरा फॉर्मूला आ गया डिस्क. दूसरा फॉर्मूला आ गया डिस्क. डिस्क मींस सॉलिड सिलेंडर बेसिकली, और उसका मोमेंट ऑफ इनर्शिया अबाउट सेंट्रॉयड, उसका मोमेंट ऑफ इनर्शिया अबाउट सेंट्रॉयड परपेंडिकुलर टू द प्लेन इज mr स्क्वायर बाई 2. डिस्क का, सॉलिड सिलेंडर का mr स्क्वायर बाई 2. अच्छा, अगर डिस्क नहीं है, रिंग है, ये तो डिस्क है, अगर वो रिंग है तो क्या है? रिंग का mr स्क्वायर. रिंग क्या होता है? हॉलो सिलेंडर. जितने मैं तुम्हें फॉर्मूला बता रहा हूं उतने में से ही क्वेश्चन आता है, ज्यादा नहीं करना है. सर रिंग का मोमेंट ऑफ इनर्शिया कितना होता है? mr स्क्वायर. हॉलो सिलेंडर का mr स्क्वायर. m क्या है? मास. r क्या है? रेडियस. अच्छा सर, डिस्क का, व्हील का, फ्लाई व्हील का, डिस्क का, व्हील का, फ्लाई व्हील का mr स्क्वायर बाय 2. सॉलिड सिलेंडर का mr स्क्वायर बाय 2. कौन सी एक्सिस पे? ये जो उसके सेंटर से होके जाती है, राइट? और पैरेलल एक्सिस थ्योरम तुम्हें पता है, अगर तुम्हें किसी और एक्सिस पे निकालना हो तो सेंट्रॉयड के एक्सिस के अबाउट प्लस मास इनटू डिस्टेंस बिटवीन द टू एक्सिस, वो आप पैरेलल एक्सिस थ्योरम लगा सकते हैं. अगर मैं तुम्हें एक सॉलिड स्फीयर दे दूं तो सॉलिड स्फीयर का कितना होता है? 2/5 mr स्क्वायर. तुम्हें लिखना नहीं है, मैं पहले ही तुम्हें कंडीशन बता चुका हूं, लिखना नहीं है, अंडरस्टैंड करना है. मैं तुम्हें सारा डॉक्यूमेंट भेज रहा हूं व्हाट्सएप के ऊपर, डोंट वरी. सॉलिड स्फीयर का 2/5 mr स्क्वायर एंड हॉलो का 2/3 mr स्क्वायर. तो सर इंजीनियरिंग मैकेनिक्स के लिए मेरे को मोमेंट ऑफ इनर्शिया के कितने फॉर्मूला से काम चलाना पड़ेगा? आपको ये रॉड का फॉर्मूला, डिस्क का फॉर्मूला, स्फीयर का फॉर्मूला सफिशिएंट है, प्लस एनुलर डिस्क. नाउ एनुलर डिस्क क्या बीमारी है, एनुलर डिस्क क्या चीज है, उसका फॉर्मूला किस लिए चाहिए? लेट मी नाउ टेल यू अबाउट दैट. एनुलर डिस्क भाई ये होती है जिसमें इंटरनल रेडियस भी होता है, एक्सटर्नल रेडियस भी होता है. एनुलर डिस्क ये चीज होती है जिसमें इंटरनल रेडियस भी है, जिसमें एक्सटर्नल रेडियस भी है, और सारा मास इस तरीके से डिस्ट्रीब्यूटेड है. दिस इज कॉल्ड एनुलर डिस्क. और एनुलर डिस्क का एक फॉर्मूला, आपका एनुलर डिस्क का क्वेश्चन आ चुका है एग्जाम के अंदर पहले, तो आई एम वेरी श्योर ही माइट आस्क यू द क्वेश्चन अबाउट एनुलर डिस्क अगेन. तो एनुलर डिस्क का मोमेंट ऑफ इनर्शिया देखो क्या है, वेरी वेरी सिंपल, mr1 स्क्वायर प्लस r2 स्क्वायर डिवाइडेड बाय 2. दिस इज द फॉर्मूला ऑफ एनुलर डिस्क. रिमेंबर इट, वेरी वेरी इंपॉर्टेंट. अच्छा सर एक बात बताओ, क्या ये एनुलर डिस्क सॉलिड डिस्क बन सकती है? सॉलिड सिलेंडर बन सकता है? एनुलर डिस्क बिल्कुल बन सकता है. अगर मैं r1 को 0 कर दूं तो डिस्क बन जाएगा. r1 को 0 कर दो तो पूरे का पूरा सॉलिड हो जाएगा. r1 अगर 0 कर दो तो mr स्क्वायर बाय 2 हो जाएगा, वही फॉर्मूला जो आपने किया. अच्छा क्या ये रिंग भी बन सकती है? बिल्कुल बन सकती है रिंग. आप r1 को r2 के बराबर कर दो, सारे मास को पेरिफेरी पे रख दो, तो ये रिंग बन गई. r1 को r2 के बराबर कर दो, फॉर्मूला mr स्क्वायर बन गया. तो यही एनुलर डिस्क आपकी किस में कन्वर्ट हो जाएगी? यही एनुलर डिस्क आपकी रिंग में या डिस्क में कन्वर्ट हो जाएगी. बट फॉर्मूला इज इंपॉर्टेंट. अब इस चीज में एक चीज ध्यान से याद रखना, यहां पे जो अगर ये रोलर बॉडी है, रोल कर रही है, तो जो ट्रांसलेशन वेलोसिटी है वो तो v है. बता सकते हैं पेरिफेरल वेलोसिटी कितनी है? यहाँ पे पेरिफेरल वेलोसिटी विल बी r2 इंटू ओमेगा. r1 इंटू ओमेगा नहीं होगा, r2 इंटू ओमेगा होगा. ये सबसे इंपॉर्टेंट कैच है इस पर्टिकुलर एनालिसिस के लिए. तो आपका जो ट्रांसलेशन वेलोसिटी होगी दैट विल बी r2 into ओमेगा। पेरिफेरल वेलोसिटी जो आपकी ट्रांसलेशन वेलोसिटी है वो v है, और r2 ओमेगा आपकी पेरिफेरल वेलोसिटी है, टेंशियल वेलोसिटी है। ये दोनों बराबर होंगे तभी नो स्किड कंडीशन आपका आएगा। एनी हाउ दैट इज व्हाट वी शुड नो। अब देखो क्या है, हम निकाल रहे हैं किसी भी रोलर बॉडी के लिए काइनेटिक एनर्जी। तो अब मेरे को इन दोनों को जोड़ना है। कैसे जोड़ सकते हैं? एग्जांपल लेते हैं। लेट अस से वी हैव अ डिस्क। अगर हमारे पास डिस्क है तो बता सकते हैं डिस्क का मोमेंट ऑफ इनर्शिया कितना होता है? यस, mr²/2 होता है। डन। तो यहां पे आई की जगह रख देते हैं। तो टोटल काइनेटिक एनर्जी कितनी हो गई सर? हाफ ऑफ mv² प्लस हाफ ऑफ आई की जगह रख दो mr²/2 इंटू ओमेगा स्क्वायर। लेकिन क्या है, आर ओमेगा किसके बराबर है? v इज इक्वल टू आर ओमेगा। ये कैसे पता लगा? ये नो स्लिप कंडीशन से पता लगा। v इज इक्वल टू आर ओमेगा। तो कितना हो गया ये? हाफ ऑफ mv² प्लस 1/4 mv²। तो कितना हो गया ये हो गया 3/4 mv²। ये हमारे पास टोटल काइनेटिक एनर्जी आ गई, दैट इज 3/4 mv²। नाउ दिस इज समथिंग व्हिच इज वेरी वेरी इंपॉर्टेंट। और फिर वो यहां से एंटर कर जाता है पोटेंशियल एनर्जी वाले चैप्टर में। यहां से एंटर कर जाता है पोटेंशियल एनर्जी वाले चैप्टर में, और क्वेश्चन फ्रेम होता है। तो वन क्वेश्चन इज फ्रेम्ड फ्रॉम हियर आल्सो। शुड आई टेल यू नाउ व्हाट काइंड ऑफ क्वेश्चन इज गोइंग टू फ्रेम? सो ही इज गोइंग टू आस्क यू कि भाई एक ऐसे रोलर है और उस रोलर को मैंने रखा हुआ है किसी हाइट पे, और वो हाइट जो है वो है h हाइट पे मैंने इस रोलर को रख दिया। जब ये h हाइट वाला रोलर नीचे सरफेस पे पहुंच जाएगा तो उसकी वेलोसिटी बताओ। रोलर उसने बता दिया भाई सॉलिड स्फीयर है। रोलर जो है वो सॉलिड स्फीयर है। क्वेश्चन आपको क्लियर हो गया? एक रोलर है जो सॉलिड स्फीयर है और उसको मैंने h हाइट पे रखा है, स्टेशनरी, वेलोसिटी नहीं है उसके अंदर। और जब मैंने उसको छोड़ा तो रोल करते करते यहां पहुंच गया, रोल करते करते यहां पहुंच गया। आपको उसकी वेलोसिटी बतानी है, v बताना है कितना है। क्या कंसेप्ट यूज करेंगे सर? रोलर की पोटेंशियल एनर्जी mgh, रोलर की काइनेटिक एनर्जी हमें निकालनी है। लेकिन कौन सी काइनेटिक एनर्जी? ट्रांसलेशन, रोटेशन या टोटल? आंसर इज टोटल। बताओ जरा कैसे निकालेंगे सर? टोटल तो होती है हाफ ऑफ आई ओमेगा स्क्वायर प्लस हाफ ऑफ mv²। v निकालने को बोल रहा है। अब रोलर का आई बता सकते हैं कितना है सॉलिड स्फीयर का? हाँ सर, 2/5 mr²। ये हमारे रोलर का क्या होता है? मोमेंट ऑफ इनर्शिया होता है। और v किसके बराबर होता है? v इज इक्वल टू आर ओमेगा के बराबर होता है। तो चलो निकालते हैं इसको। हाफ ऑफ दिस इज 2/5 mr² ओमेगा स्क्वायर प्लस हाफ ऑफ mv²। राइट। अब ये कितना आ गया? 2 कैंसिल हो गया, तो 1/5 mv² प्लस 1/2 mv²। तो भाई टोटल काइनेटिक एनर्जी कितनी हो गई? 7/10 mv²। तो 7/10 mv² को तुम किससे कंपेयर कर दो? कंपेयर कर दो इससे, तो हमारे पास आ गया 10/7 gh√। ये आपका क्वेश्चन था कि भाई अगर मैं किसी एक रोलर जिसको h हाइट पे रख दूं और छोड़ दूं तो जब वो नीचे पहुंचेगा तो बताओ उसकी वेलोसिटी कितनी होगी। अंडरस्टूड दिस क्वेश्चन? यही क्वेश्चन को मैं थोड़ा सा जो एग्जाम में आया था घुमा के पूछता हूं। लेट्स सी वेदर यू आंसर दिस क्वेश्चन। मैंने आपको अब एक ऐसा सरफेस, ऐसा एक बॉडी दिया, एक ऐसा बॉडी मैंने आपको दिया, वो रोल नहीं कर रहा है, स्लाइड कर रहा है, h हाइट के ऊपर पड़ा हुआ है, h हाइट के ऊपर वो पड़ा हुआ है। बताओ जब ये नीचे पहुंच जाएगा तो इसकी वेलोसिटी कितनी होगी? अब ये रोलर नहीं है, अब ये क्या है? तुम्हारी बॉडी है जो ट्रांसलेट कर रही है, रोलर नहीं है ये। तो बताओ अब इसकी वेलोसिटी कितनी हो जाएगी? तो भाई इसकी तो वेलोसिटी ओनली, इसकी काइनेटिक एनर्जी कितनी है? हाफ ऑफ mv²। पोटेंशियल एनर्जी कितनी है? mgh। तो कर दो हाफ ऑफ mv² इसको इक्वल, ये कैंसिल हो जाएगा, तो v इज इक्वल टू रूट ऑफ 2gh। ये तो बहुत ही आसान था, इसमें क्या ट्रबल है? सो दिस इज नॉट द टिकलिश क्वेश्चन। टिकलिश क्वेश्चन वाज जो आपने बेसिकली स्लाइडिंग, सॉरी रोलिंग बॉडी का काइनेटिक एनर्जी निकाला। तो रोलिंग बॉडी का काइनेटिक एनर्जी निकालना और उसको पोटेंशियल एनर्जी से कंपेयर करना, वहां से एग्जाम में क्वेश्चन आता है। चलो पीछे चलते हैं, इसको भी निकालते हैं। सो आई एम टेलिंग यू क्वेश्चन एग्जाम में कहां कहां से आता है। तो अभी तक कितने पॉइंट्स मैंने बताया जहां से क्वेश्चन आता है? यस सर, ऐसा है। एक तो काइनेटिक एनर्जी से क्वेश्चन आता है रोलिंग बॉडी का, और कहां से आता है? अच्छा सर, रोलिंग बॉडी के किसी पर्टिकुलर पोजीशन पे वेलोसिटी और एक्सेलरेशन निकाल देने से भी क्वेश्चन आता है। और कहां से क्वेश्चन आता है? सर नॉन यूनिफॉर्म सर्कुलर मोशन से भी क्वेश्चन आता है। गुड। और कहां से क्वेश्चन आता है? और सर क्वेश्चन यहां से आता है कि अगर उसने आपको रोटेशनल बॉडी दे दिया जिसमें अल्फा इज कांस्टेंट, यूनिफॉर्मली एक्सेलरेटेड मोशन दे दिया है लेकिन रोटेशनल मोशन दिया है, वहां से क्वेश्चन आता है। और कहां से क्वेश्चन आता है सर? और क्वेश्चन आता है आपका कंजर्वेशन ऑफ एंगुलर मोमेंटम, I1 ओमेगा 1 I2 ओमेगा 2 से क्वेश्चन आता है। और कहां से क्वेश्चन आता है? और आपका क्वेश्चन मोशन में से आ सकता है जिसमें वेलोसिटी एक्सेलरेशन निकालने को बोल सकता है। तो चलो आगे चलते हैं। These are some of the points from where he might ask you to calculate some particular thing. He might ask you to calculate certain things from here. Okay. Now let me tell you next part from where he asks you a question, and that is related to something which is called instantaneous center, and that is very important term. So what is instantaneous center? Let me talk about instantaneous center now. So I talk about I center, instantaneous center. Instantaneous center. Let me tell you the name. You know what is the instantaneous? At that moment, particular moment को instant बोलते हैं. At particular moment, what is the center of rotation? That is called instantaneous center. Okay, done. एक कार है ऐसे जा रही है हाईवे के ऊपर, एक कार है हाईवे के ऊपर जा रही है. Tell me one thing. It is having translation motion और circular motion. एक कार हाईवे के ऊपर जा रही है, बताओ ट्रांसलेशन मोशन है कि सर्कुलर मोशन है? आप बोलोगे सर वो तो ट्रांसलेशन मोशन है. ओके, वेरी गुड. बट वो अर्थ के ऊपर अगर मैं ले लूं और अर्थ के रेडियस के हिसाब से देखूं, दिस इज द सेंटर ऑफ अर्थ, एंड मैं अर्थ के रेडियस के हिसाब से देखूं, तो आप बोलेंगे कि दिस v इज इक्वल टू r इंटू ओमेगा. सी दिस केयरफुली. एक कार है जो हाईवे पे जा रही है, हाईवे अर्थ के ऊपर बना हुआ है, अर्थ के सेंटर से कार तक का डिस्टेंस, रेडियल डिस्टेंस है r, एंड हम जानते हैं कि जब कोई बॉडी ट्रांसलेट करेगी v इक्वल टू r ओमेगा, तो ऐसा लगेगा कि v इक्वल टू r ओमेगा. अब मैं ये बोल सकता हूं कि कार एक एंगुलर वेलोसिटी डिस्प्ले कर रही है, कार एक एंगुलर वेलोसिटी डिस्प्ले कर रही है ओमेगा. अब सुनना ध्यान से, इंस्टेंटेनियस सेंटर का मीनिंग क्या है? सर इंस्टेंटेनियस सेंटर मींस एवरी बॉडी विच इज हैविंग अ मोशन, every body which is having a motion, that motion is combination of either translation और rotation. उन दोनों को जोड़ के मोशन उसकी बनती है. या तो ये प्योरली ट्रांसलेशन हो सकता है, प्योरली रोटेशन हो सकता है, या उनका कॉम्बिनेशन हो सकता है. जो बॉडी प्योरली ट्रांसलेट भी कर रही है, जो बॉडी प्योरली ट्रांसलेट भी कर रही है, उसका भी एक ऐसा सेंटर है जिसके अबाउट आई कैन एज्यूम दैट इट इज डिस्प्लेइंग प्योरली रोटेशनल मोशन, जो मैंने यहां पे अज्यूम किया. नो डाउट दिस आर इज अ वेरी बिग डिस्टेंस. कितना है अर्थ का रेडियस? 6400 किलोमीटर. तो आर तो बहुत ज्यादा है, इनफाइनाइट है ऑलमोस्ट. दैट मींस अगर कोई बॉडी ट्रांसलेट कर रही है तो सर क्या हम ये बोल सकते हैं कि वो एक पर्टिकुलर पॉइंट के अबाउट प्योरली रोटेट भी कर रही है, और उस पॉइंट को क्या बोलते हैं? इंस्टेंटेनियस सेंटर. और ट्रांसलेटिंग बॉडी का इंस्टेंटेनियस सेंटर कहां होता है? इन्फिनिटी. मैथमेटिक्स वाला इन्फिनिटी मत सोचो, इन्फिनिटी मींस वेरी लार्ज, समथिंग लाइक दिस 6400 किलोमीटर. तो इफ अ बॉडी इज ट्रांसलेटिंग ओनली, इट कैन आल्सो बी अज्यूम्ड to be displaying purely rotational motion, but yes, the center of rotation is at very large distance, infinite. That is the meaning of it, and hence we can say, okay, for translating body, the instantaneous center is located at axis which is perpendicular or normal to the motion. दोबारा इसको ध्यान से देखना. Instantaneous center of a translating body is to be located by drawing a normal or perpendicular to the direction of velocity, and the instantaneous center will be on that line only, somewhere on that line only. इसके बोलते हैं instantaneous center. तो see, there are certain bodies जिनका I center हमें पता होता है, प्योरली रोटेटिंग बॉडी. जैसे फैन है, फैन का आई सेंटर क्या है? उसका जो सेंटर ऑफ रोटेशन है वही आई सेंटर है. तो प्योरली रोटेटिंग बॉडीज का आई सेंटर कहां पे होता है? सेंटर ऑफ एक्सिस पे ही होता है. और ट्रांसलेटिंग बॉडी का आई सेंटर कहां होता है? वो सर बहुत इनफाइनाइट डिस्टेंस पे होता है. और बाकी बॉडीज का कहां होता है? उसको निकालना पड़ता है. और बाकी बॉडीज का जो आई सेंटर निकालना पड़ता है, उसके बेस पे बहुत से क्वेश्चन पूछे गए हैं रोटेशनल मोशन में, और मैं अब बड़े इंटरेस्टिंग आपको पॉइंट्स देने वाला हूं इसका आई सेंटर्स के बारे में. इसको प्लीज ट्राई टू अंडरस्टैंड इट वेल. आई सेंटर बाकी बॉडीज के लिए कैसे निकालते हैं? मैंने आपको बताया कि वेलोसिटी जो है, डायरेक्शन ऑफ वेलोसिटी और आई सेंटर से अगर मैं कनेक्ट कर दूं तो इनके बीच में एंगल कितना होता है? 90 डिग्री होता है. दैट मींस अगर मेरे को बॉडी की वेलोसिटी की मैग्नीट्यूड नहीं, डायरेक्शन पता चल जाए, बॉडी की वेलोसिटी की डायरेक्शन पता चल जाए कि किस डायरेक्शन में बॉडी मूव कर रही है, तो उसको परपेंडिकुलर ड्रॉ करके, उसके ऊपर परपेंडिकुलर ड्रॉ करके मैं आई सेंटर कहां पे होगा वो लाइन खींच सकता हूं। दोबारा देखो ध्यान से, इफ आई नो द डायरेक्शन ऑफ वेलोसिटी of the body, just draw normal to that, just draw perpendicular to that, and you will be sure that eye center of this body will be on this line only somewhere. Now this concept is used to identify the eye center of the body. And why do you identify eye center? Because we want to find out the angular velocity of the body at that particular moment. Now let me now give you the method to find eye center of a body. Let me give you this body. भाई ये बॉडी का आई सेंटर निकालो, इस बॉडी का आई सेंटर निकालो। तो आप मेरे को क्या बोलोगे, सर इसके ऊपर दो पॉइंट्स दे दो, इसके ऊपर दो पॉइंट्स दे दो ए एंड बी, जहां पे मेरे को वेलोसिटी की डायरेक्शन पता हो। ओके, मैंने तुम्हें बोला भाई ए के ऊपर वेलोसिटी इस डायरेक्शन में और बी के ऊपर वेलोसिटी इस डायरेक्शन में। ए के ऊपर वेलोसिटी इज इन दिस डायरेक्शन, बी के ऊपर वेलोसिटी इज इन दिस डायरेक्शन, एंड दीज टू पॉइंट्स आर ऑन द बॉडी। वेयर इज द आई सेंटर ऑफ दिस बॉडी? एंड बिलीव मी, one question can be framed on this concept, okay, find the eye center. One question can be framed on this, that find the eye center. All you need to do is draw perpendicular here, draw perpendicular here, wherever it meets, because the line joining eye center with the velocity should be perpendicular. So wherever it meets, that gives you eye center. And I can very beautifully frame a question here. I can give you question first, VA, VB, where will be eye center? Approximate. 1 point here, 1 point here, 1 point here, 1 point here. So one question of 1 mark can be framed on this concept, how to identify eye center. And you know, the typical and the most beautiful example of identifying eye center is ladder problem. You know what is ladder problem? And I'm going to discuss with you 3 questions are asked from ladder problems. 3 questions are asked, different questions are asked from ladder problem. I'm giving you a ladder. This is ladder point A, this is ladder point B. Tell me one thing, if this ladder slides, which direction it is going to move? Slide it down, ऊपर की तरफ थोड़ी चली जाएगी, because of its weight, because of its weight, you know, this ladder is going to, this end is going to go in this direction, and this end is going to go in this direction. I told you that this ladder, no doubt, it is not a purely rotating body, it is not a purely translating body, it is a combination of two. So if I want to find out at particular moment what is the angular velocity of ladder, how to find out angular velocity of ladder? You need to find out its eye center first. And eye center कैसे find out करना है? Locate 2 points on this ladder at which you know the direction of velocity. So I know the direction of velocity of A, I know the direction of velocity of B. Just draw the perpendicular there. Okay sir, perpendicular गिराते हैं, इसके ऊपर भी perpendicular गिराते हैं, मैंने perpendicular फेंका, जहां पे ये परपेंडिकुलर आपस में मिलेंगे, जहां पे परपेंडिकुलर मिलेंगे, that is the eye center of this ladder, that is the eye center of this ladder. Okay, now what is the beauty of eye center? Why we found the eye center? Let me give you some more data here. Let's say the length of the ladder is L. Let us say this angle is theta, so this length is L cos theta, and this length is L sin theta. L cos theta and L sin theta, right? Now let us say this ladder is having angular velocity omega. He is going to ask you to find out angular velocity of the ladder as it slides down. Let us say that angular velocity is omega. Now can you tell me what is VA? Yes, VA is equal to IA into omega. What is IA? I to A tak ka distance is IA. Why I am saying IA? Because if this is the center, VA is the peripheral velocity, omega is the angular velocity, so omega into IA is the VA. And what is VB? VB is IB into omega. So VA and VB can be calculated like this. Now, what is IA? IA is L cos theta. What is IB? IB is L sin theta. So if you take the ratio of these two, you can find out the relation between VA and VB. Let's divide. So VA over VB is equal to IA over IB. And what is IA? L cos theta over L sin theta. This comes out to be cot theta. That means VB is nothing but VA into tan theta. So if you give me the velocity of one end of the ladder, if you tell me, sir, this end is sliding down with velocity 1 meter per second, and this is 45 degree. Tell me the velocity VB. So I will say VB will be equal to VA into tangent 45 degree. That will also come down with 1 meter per second. So if you give me 60 degree, this will be root 3. So you can find out velocity of both the ends. Plus, he might also ask you to calculate the angular velocity of ladder. So omega will be VA over IA. I know L, I know theta, IA can be calculated. So this part is calculated from there. So I center is a very, very important concept. And you know what? Ladder में से angular acceleration का concept भी आपका instantaneous center से related है. By the way, have you understood how I center is to be calculated? Let me now summarize the concept of I center. Let me summarize the concept of I center for you. I tell you, I center, how to identify I center. If there's a purely rotating body, then I center is the center of rotation, something like ceiling fan. If the body is a purely translating body, then I center is at infinity. If it is sum of these two, I center is to be found like this. Now I give you two cases from where direct question has been asked. This is the body, it is moving on a curved path. This is the body, sliding body, moving on a curved path. Where will its I center be located? Answer is, its I center will be located on a line perpendicular to this surface. On a line perpendicular to this surface. Think it carefully. If there is a sliding body on a curved surface, where will its I center be? Not on center of curvature, but on a line joining this particular curved path. Okay. If I give you a rolling body, where will its I center be? You know, for a rolling body, I center is point of contact. Always remember, because I center is the instantaneous center. And if I ask you, can you tell me a point on a roller, a point on a rolling body where velocity is 0? Listen my question again carefully. Can you tell me a point on a rolling body where velocity is 0? Only point where velocity is 0 is C. Just now I told you, no slip condition. C के ऊपर velocity नहीं हो सकता, otherwise slip हो जाएगा. So C is the point where there is no velocity, and hence you say no velocity. And the point where there is no velocity is I center. So rolling body का I center, point of contact पे. Purely rotating body का I center, center of rotation. Translating body का I center, infinity. A body which is translating or sliding on a curved path, I center is on normal. And now I give you the most ticklish question here. If instead of this I give you a roller, if instead of this I give you a roller, tell me, if the roller is moving on a curved path, if a roller is moving on a curved path, then tell me where will be the I center. And remember this, for a roller body on a curved path, I center is on point of contact only. So I center is on the point of contact. That is what you should know. So where is the I center of purely rotating body? So understood now? Translating body, purely rotating body, rolling body, a sliding body on curved path, a roller on a curved path, where I center is located. And if I want to find out I center for other bodies, this is how it is to be obtained. Now let me give you another concept here. And that concept is related to ladder problem. This is related to ladder problem. You know, from the ladder, 3 type of questions he will going to ask you. Force equilibrium. He's going to ask you 3 problems. One is force equilibrium or equilibrium, state of equilibrium. Ladder is in the state of equilibrium. Second is angular velocity. Third is angular acceleration. So he's going to ask you to find out some particular forces acting on the ladder. He's going to ask you angular velocity of ladder. He's going to ask you angular acceleration of the ladder. Now these 2 things will be obtained using the concept of I center. These 2 will be done by using the concept of I center. That is what he's going to do. Now force equilibrium I discussed in the previous class also. Let me take it now also. This is the body in the state of equilibrium. It is not moving. So this is not moving. This case is not moving case. It is in the equilibrium. These 2 are moving. That's the reason we are getting omega and we are getting the alpha. Okay, what is the name of this end? A. What is this end? B. What is the normal direction? RA. What is the normal direction? RB. What is the weight of this? W. What is the length of this? L. What is this distance? L cos theta. What is theta? This one. What is this distance? L sine theta. Okay, done. Do you have friction? Yes. Fa. Do you have friction? Yes. Fb. Why? Because if ladder slides, it is going to slide in this way. It is going to slide in this way. Now, if all the horizontal forces are to be balanced, if all the vertical forces are to be balanced, can you write the equation? Yes. So let's balance all the horizontal forces. Ra is equal to f of b. And what is f of b? Mu into rb. What is mu? Coefficient of friction. Yesterday we did it. So mu into rb is f of b. Mu into ra is f of a. So horizontal forces, ra is balanced by fb. Vertical forces, okay, fa plus rb is equal to w. What is fa? Mu into ra. What is fa? Mu into ra. Normal reaction at a plus rb is equal to w. Equation number 2. Now these two equations are not sufficient. So what we need to do? Let's take the moment about point b. Let's take the moment about point b and equate it to 0. What do you understand by equilibrium? Net force acting on the body is 0. Net movement is also 0. So net movement of all the forces at point b is 0. So let's take net force of all the movement. Ra. What movement Ra produces? Ra into L sine theta. Ra into L sine theta. Clockwise. Good. Fa plus Fa is also going to produce some movement into L cos theta. That is also clockwise. So Ra into L sine theta, Fa into L cos theta. These produce clockwise movement. What about W? W produces anti-clockwise movement, L cos theta by 2, because you see the line of action of W is basically L cos theta by 2. This is equation number 3. So we have got 3 equations, 1, 2, 3. Using these 3 equations, we can solve it. We can solve it and we can calculate the forces. Now second case comes. Second case, this is the first case. Most generic case is this. This is the most generic case. Second case is no friction on the wall. So f of a is 0. No friction on the wall. There is no friction here. That is possible. If there is no friction on the wall, fa will be 0. Just put fa 0 and solve it. Second case. Third case is no friction on the surface also. That means f of b is also 0. F of b is also 0. So sir, should I make f of b also 0 and solve? No, you cannot do that. So if there is no friction here, if there is no friction here, the ladder cannot stop or be in equilibrium because friction was making it at rest. So then what is to be done, sir? Then the third case is you need to apply force at point B to bring it in equilibrium. You need to apply this force P. Now let's basically solve it. This is RA, this is RB, this is W. Understand? No friction. All horizontal forces, RA is equal to P. Horizontal forces are balanced. RA is equal to P. I need to apply force P. RA is equal to P. Okay, what about RB? RB is equal to W because that is only vertical force. Now take the moment of all forces at point B. That means RA into this distance is L sine theta, and that is balanced by W into L cos theta by 2. From here you get RA, or from this you get P. From here you get RA, and from this you get P. Because understand, RA is going to produce movement, W is going to produce movement, and you are going to analyze this particular ladder. So this is the first part from where question of ladder is asked. Question of ladder is asked from this particular part, like find out the forces, and that is we have done that particular part yesterday also. Now I come to second part. Second part is the velocities of ladder. Second part is velocity of ladder. So this part is VB, this part is VA, this is A, this is B. Now find out what is the angular velocity of ladder. Now for that, what we need to do, we need to find out the I center. You understand? I center, we need to find out the I center. And how to do now? Let us say a particular point omega is the angular velocity. So what is VA? Sir, VA is IA into omega. Okay, what is VB? Sir, IB into omega. What is IA? L cos theta. What is IB? L sin theta. So use these two terms. VB over VA is IB over IA. IB is nothing but L cos theta, and I think VB is equal to IB into IB is L sin theta, sorry. So this comes out to be tangent theta. So what we can understood, VB is equal to VA into tangent theta. And if I want to find out omega, that is VA over IA. IA is nothing but L cos theta. So exam में ये दो questions आएगा. Exam is going to ask you these two questions, that if end A has velocity this, what is the velocity of end B? That is the question he's going to ask you. If end A has this velocity, what is the end B has velocity? And now I'm going to discuss something for which I want your maximum attention. Third case, angular acceleration of the ladder. Are you attentive? If you are not, bring your maximum attention this side, because this question is going to come. So now I'm going to find out alpha for ladder. This is the most important topic for which I want your full attention, or else you guys are not going to understand it. Okay, now let me make this particular diagram here. Because of its weight W, which is located at centroid G, this is L cos theta, and this distance is L cos theta divided by 2. Total is L cos theta. This is L sin theta. And now this one is I center for ladder. This is the I center for ladder. Tell me, because of this weight, this ladder falls down. Because of this weight, this ladder falls down. And you have to tell what is the angular acceleration of this ladder. What is the angular acceleration of this ladder? Alpha. Let me tell you now, you have seen this formula, have you not? Torque is equal to I into alpha. Now, what is the torque acting on ladder? See carefully. mg into, now first tell me, this ladder is rotating purely about which point? I will say this ladder is purely rotating about I center. This ladder is purely rotating about I center. Okay, so can you calculate the torque acting at the instantaneous center? So torque is equal to force into the minimum distance from line of action of force from the I center or from the center of rotation. Don't you know how to calculate the torque acting on a door? Force applied multiplied by distance from the hinge point, minimum distance. Force applied is W. I'm not considering frictions here, and moreover I'm considering the free body diagram of ladder. So force applied is W, and line of action from I center is L cos theta into L cos theta divided by 2. That is the torque acting on the ladder. As I told you, this is the most important case, and I want your attention. So ladder is purely rotating about point I. So what is the torque acting on the ladder at this moment? Sir, mg or W into L cos theta by 2. That is the torque acting at this ladder about point I. Good. What is the moment of inertia of the ladder about this point I? Do you know what is the moment of inertia of this ladder about point G? Yes. I know moment of inertia of this ladder about point G as ml square by 12. About centroid, what is the moment of inertia of the rod of mass m, length L, about centroid? Ml square by 12. Just now I gave you formula, right or not? Ml square by 12. Now this ml square by 12 is about this, but I want to know about this point. So which theorem should I use? I know about this axis. I want to know about this axis. I need to use parallel axis theorem. Do you know this distance? Very simple. This diagonal and this diagonal are going to have same length. What is the length of this? L. What is the length of this? L. And this is the half length. This is L by 2. Right or not? So what is the moment of inertia of the ladder about I center is equal to moment of inertia of the ladder about centroid plus mass into distance between the two axes square. So mass into L by 2 square. If you add these two, you will get it ml square by 3. It looks like moment of inertia of the ladder about one of the axes, but that is coincidence. Don't get confused because of that. So what is the moment of inertia of this axis about this? Ml square by 12. What is the moment of inertia of this ladder about this? Ml square by 3. What is the moment of inertia of this ladder about this I center? Ml square by 3. So what we get is ml square by 3. What I want to find? Alpha. Let's go there. M G L cos theta by 2 is equal to M L square by 3 into alpha. M gets cancelled out, 1 power of L gets cancelled out. What we wanted to find out is alpha. And what is the value of alpha coming now? Alpha is equal to 3 by 2 cos theta by L. 3 by 2, then this is G cos theta by L. Believe me, this direct question can be asked from here. What is angular acceleration of the ladder? 3 by 2. So what alpha you are getting? Alpha is equal to 3 by 2. It goes this side. G cos theta over L. That is the value of angular acceleration of the ladder. So now I am very sure you have understood how this entire thing is to be calculated. Let me go back. Have you understood this? Have you understood this? This is the part of ladder. From the velocity, this is force equilibrium of the ladder, and this is instantaneous center. How we are to find out instantaneous center? Let me now, I think I give you the moment of inertia formulas, and then we go for some kind of numericals. So okay, first of all, formula: rod of mass m and length L, ml square by 3 about this axis, and about this ml square by 12. Okay, so what is disk? mr square by 2. This is radius. Disk is solid cylinder. Disk is solid cylinder also. Okay, then I ask you about the ring. Ring and hollow cylinder is the same thing. So this is r mass m. So if I talk about ring, this is mr square. Okay, now I say about solid sphere. Sir, solid sphere is 2 by 5 mr square, and hollow sphere, sir, hollow sphere is 2 by 3 mr square. Then what is for annular disk? Sir, for annular disk it is mr1 square plus r2 square divided by 2. This is the formula for annular disk. That is how the moment of inertia is to be calculated for annular disk. That is the meaning of this particular part. Now I think I have done more or less all the points, important points I have discussed with you, and we are ready to now go for really good questions here. Now what I do is, I think I should save it for you, right? Let me save it for you. I'll send you all these things only. So when I go back, yes, I save it, and I save it in where? I save it as confirm here. So this is saved now, right? And I will send it to you. I'll send you the same document which I saved. So let's say whether you get it. Now let me go for some numericals here. Previous years asked question numericals. So if you've understood this concept, believe me, for the last 15-20 years, what 100 questions have been asked, 100 odd questions have been asked. Out of those 100 questions, some 20 questions, no, not 20 questions, I think some 15 questions are based upon these particular concepts only. Okay, now let me go again and go and solve these questions for you. Okay, let me give you first question, and this is a really good question. He has given you a circular disc. See this carefully. He has given you a circular disc, and this circular disc is in contact with two more plates. This circular disc is in contact with two more plates. Radius of the circular disc is r. This point is p. This point is q. Let me read this question for you. But before that, let me give you the diagram here. This is a really good question based on instantaneous center only. There's a circular disk of radius r, and it is basically confined to roll without slipping at P and Q. So there's a circular disk of radius r, and it is so confined, it is so restricted, it is going to roll without slipping at point P and Q. If plate have velocities as shown, what is the magnitude of angular velocity of the disk? What is the magnitude of angular velocity of the disk? And the values given are V over R, then V over 2R, then another answer is 2V over 3R, 2V over 3R, and the next is 3V over 2R, 3V over 2R. So these are the four answers which are given to us. So there is a disk which is in contact with these plates, and it is going to slip like this. Okay, now what is this question? You will say, sir, angular velocity. Okay, let me ask you a question. Can you tell me the point about which this disk is rotating? Listen this question, and I want to see the answer there. Can you tell me the point? Let's say this point is O. Can you tell me the point about which this disk is going to rotate, or I center of the disk? Answer me. Do you think it is O or not? Do you think it is O or not? Is this point O or not? It cannot be O. Why? Because if it is O and it is going to have angular velocity about O, this velocity and this velocity r omega will be same, but it is not given same. It is given V, this one is given 2V. That means this disk certainly is rotating about some axis, about some basically point which is not at O. But how to find out about which point it is rotating? How to find out about which point it is rotating? Do you know the direction of velocity? Yes. Let me now make another diagram here. I told you whenever you want to find out the instantaneous center, you tell me any 2 points on the body, you tell me any 2 points on the body at which you know direction of velocity. Okay, I know VP in this direction, I know VQ in this direction. Now draw perpendicular on this. That means I center is somewhere here only, on this line only. Okay, good. Let us say this is displaying some kind of angular rotation. Let us say omega. Omega is what we want to find out. Now visualize that its center of rotation of this disk is at point C, and C is not at O. C is not here. C is at any other point. Now let us say C से लेके P तक का distance is x. So C से लेके Q तक का distance is diameter in minus x. Understood this? If this distance from C to P is x, then total distance is 2r, diameter minus x. So this is the distance which is left. Now, what is now VP? I will say, sir, VP is x into omega. What is x? X is the radial distance. What is omega? Angular velocity of the disk. Agree or not? And what is C? Instantaneous center of rotation. What is VQ? Sir, VQ is 2r minus x into omega. Yes, radial distance of this is 2r minus x. So what is VQ? R into omega. What is R? Radial distance from here, 2r minus x. Use these two concepts now. Now if I divide VQ with VP, what is VQ with VP? VQ is 2V, VP is a V. That is equal to 2 is equal to 2r minus x over x. Okay, so that gives me 2x, 3x, that gives me x is equal to 2r over 3. X is equal to 2r over 3. And what he has asked you to calculate is omega. So omega is equal to Vp over x. What is Vp? That is V. What is x? 2r over 3. So 3V by 2r is the answer for this question. And believe me, this question is a beautiful question. Why? Because it is based upon the concept of instantaneous center. So those of you who will assume that, let us say this disk is rotating about point O. If disk is rotating about center O, then this velocity and this velocity will be equal. These two velocities will not be equal if this disk is rotating at any other point other than center. So that point has to be on this particular line, because this line is perpendicular to the velocities. I'm sure you have understood this particular question. Okay, done. Bhai, if you have understood this question, let me take you to the next good question. And as I told you, today is the day I'm going to solve good questions, So let me, somebody asking what is the annular disk, and let me solve this question for you. There is an annular disk which has mass m, and inner and outer radii are also given. So this question is about annular disk. Annular disk किसको बोलते हैं सर? annular disk डिस्क और रिंग के बीच की चीज होती है, जिसका इंटरनल रेडियस भी होता है, एक्सटर्नल रेडियस भी होता है. नाउ ही हैज गिवन यू annular disk. He has given you annular disk of mass m and radius r and 2r. Do you understand now? This is the mass is concentrated somewhere here. So mass of this disk is given as m, inner radius is r, outer radius is given as 2r. डिस्क रोल्स ऑन द फ्लैट सरफेस विदाउट स्लिपिंग. ये देखो भाई, डिस्क जो है रोलिंग कर रही है, ये पॉइंट ऑफ कॉन्टेक्ट है, विदाउट स्लिप, नो स्लिप कंडीशन. तुम्हें पता है नो स्लिप कंडीशन से क्या मिलता है? यस, नो स्लिप कंडीशन से आपके पॉइंट ऑफ कॉन्टेक्ट के ऊपर ट्रांसलेशन वेलोसिटी एंड रोटेशनल वेलोसिटी का आपका रिलेशन इवॉल्व होता है. नाउ हाउ डू यू शो द बेसिकली बॉडी विच इज रोलिंग बॉडी? सर रोलिंग बॉडी को हम ऐसे शो करते हैं, जिसकी वेलोसिटी भी होती है और जिसका एंगुलर वेलोसिटी भी होता है, जिसकी ट्रांसलेशन वेलोसिटी भी होती है और जिसका एंगुलर वेलोसिटी भी होता है. दैट इज शोन एज द रोलिंग बॉडी. ओके, डन. द डिस्क रोल्स ऑन अ फ्लैट सरफेस विदाउट स्लिपिंग. इफ वेलोसिटी ऑफ सेंटर ऑफ मास इज v, it is given to us, if velocity of center of mass is v, then kinetic energy of the disk, आंसर चॉइस इज बी दे रखी है उसने तुम्हें. kinetic energy of the disk is 9/16 mv square. दूसरा चॉइस क्या है? 11/16 mv square. तीसरा चॉइस क्या दे रखा है? 13/16 mv square. फोर्थ चॉइस क्या दे रखा है? 15/16 mv square. तो ये भाई kinetic energy उसने आपसे पूछा कि kinetic energy बताओ कितना होगा. कैसे निकालेंगे काइनेटिक एनर्जी? किसी भी आपकी रोलिंग बॉडी की काइनेटिक एनर्जी के दो पार्ट होते हैं, एक तो रोटेशनल काइनेटिक एनर्जी और एक भाई साहब ट्रांसलेशनल काइनेटिक एनर्जी. गुड. बता सकते हैं रोटेशनल काइनेटिक एनर्जी कैसे निकालते हैं? हाँ साहब, ऐसे निकालते हैं. और ट्रांसलेशन कैसे निकालते हैं? हाफ ऑफ mv स्क्वायर निकालते हैं. अब वेलोसिटी तो दे रखा है, v दे रखा है, आंसर भी v में ही है. तो इसका मतलब ये हुआ कि रोटेशनल काइनेटिक एनर्जी को हमें ट्रांसलेशनल काइनेटिक एनर्जी में चेंज करना पड़ेगा. सही बात है. पहले तो मेरे को बताओ आई कितना है इसका. आई अबाउट दिस एक्सिस कितना होता है? वो अभी फॉर्मूला दिया तो था तुम्हें, mr1 स्क्वायर प्लस r2 स्क्वायर डिवाइडेड बाई 2. एनुलर डिस्क के मोमेंट ऑफ इनर्शिया का फॉर्मूला ये होता है. डन. r1 कितना है सर? r. r2 कितना है? 2r. r स्क्वायर प्लस 4r स्क्वायर मतलब 5mr स्क्वायर बाई 2. इफ आई एम नॉट रॉन्ग, 5mr स्क्वायर बाई 2. बहुत अच्छी बात है. अच्छा, ये वेलोसिटी कितनी है? v. ये बता सकते हैं कितनी होगी? 2r इंटू ओमेगा. ये दूसरी गलती जहां पे स्टूडेंट्स करते हैं. यू सी दिस डिस्टेंस इज 2r नॉट r, एंड हेंस ट्रांसलेशन और पेरिफेरल वेलोसिटी हियर विल बी 2r ओमेगा. r ओमेगा नहीं, 2r ओमेगा. सो दैट मींस v इज इक्वल टू 2r ओमेगा. अभी जोड़ देते हैं इसको टोटल काइनेटिक एनर्जी को, तो ऐड करो. दैट इज इक्वल टू हाफ ऑफ 5/2 mr स्क्वायर इंटू ओमेगा स्क्वायर प्लस हाफ ऑफ mv स्क्वायर. गुड. बट आई वांट टू कन्वर्ट mr स्क्वायर ओमेगा स्क्वायर इंटू mv स्क्वायर. तो क्या करना पड़ेगा? ये देखो रिलेशन, v इज इक्वल टू 2r omega. No slip condition बोलती है v should be equal to 2r omega. That is the reason if this velocity becomes equal to this, velocity here will be 0, right or not? So v will be equal to 2r omega. So that means v square should be equal to 4r square omega square. V square is 4r square omega square. Can I get 4r square omega square here? Yes. 4 से मल्टीप्लाई कर दो, 4 से डिवाइड कर दो, तो ये आ जाएगा 5/16. 4 तो पहले ही था, 4 से मैंने और डिवाइड कर दिया, 5/16 m 4r स्क्वायर ओमेगा स्क्वायर की जगह क्या लिख देता हूं, v स्क्वायर प्लस हाफ ऑफ mv स्क्वायर. कितना हो जाएगा भाई साहब, ये 13/16 13/16 mv square. That is the answer. Don't you think this was also very good question? This is a very, very good question, and you should understand the meaning of this. Annular ring, many concepts actually are clubbed together. Annular ring, and in the annular ring, he is basically trying to लिंक द टू, दोनों को जोड़ रहा है. बाकी सारे क्वेश्चन बहुत ही इजी होते हैं, जो मैंने आपको पहले बताया कि रोलर है, उसकी काइनेटिक एनर्जी पोटेंशियल एनर्जी में चेंज कर दो. Those questions are very easily done. Okay, so as I told you, I'm going to hit today on really good questions. So let me now give you this question here. Okay, let me give you this question. Now let's go to next question here, and this is next question. Okay, now this is the next question. There is a beam bar which is supported by some force. Let me read the question. A pin joint uniform rigid rod of weight W and length. So the weight of this rod is given as W and length of this rod is given as L, and yahan pe laga hua hai pin joint. So understand what problem he gives. He gives you a rod of weight W, and the support to this rod given at the end is with some force, and this is a pin joint. This is a rod of length L, weight W, and it is hinged joint, right? Now it is supported horizontally by some external force as shown. So there is some external force which is shown to you, and it is basically supported here by some kind of force as shown. Now this force is suddenly removed. This force is suddenly removed. At the instant of force removal, what will be vertical reaction developed at the support? The moment this force is removed, what will be the reaction developed at this particular point? And he gives you a couple of answers here. He gives you answers in terms of W only. He says 0, he says W by 2, W by 4, and W. That is what he gives. What is the reaction induced here if I remove force W, this particular force F? You know what is the concept here? Remove the force. The moment you remove force, what happens here is this. This W acting at distance L by 2 produces a torque which is WL by 2. Produces a torque which is WL by 2. And can you tell me this rod is going to rotate purely about which point? Yes, it is going to purely rotate about O point. That means I naught into alpha. Torque is nothing but I naught into alpha. What is I naught? Moment of inertia of this rod about point O. How do you calculate moment of inertia of rod about end point? Sir, that is ml square by 3. But what is m here? M is W by G L square by 3. That is the moment of inertia of this rod about point O. Okay. Can I find alpha through this? Yes. WL by 2 is equal to W by G L square by 3 into alpha. Okay. W gets cancelled out. So what is alpha? 3 by 2 G over L. That is the angular acceleration of this particular rod the moment I leave it. Angular acceleration. And you know what? Sometime he is going to ask you to calculate angular acceleration. He is going to ask you calculate angular acceleration. So alpha is known now. But he is not asking you to calculate angular acceleration. In fact, he is asking you to calculate what is the reaction. Let's say R induced at hinge point. Let's say reaction induced is R. Okay. Now, if this body has alpha, don't you think this body has acceleration also at the center of mass, and that acceleration is equal to r by 2, sorry, L by 2 into alpha. If I ask you what is the acceleration of center of mass, what is the acceleration of center of mass, you will say, sir, acceleration of center of mass is distance of that particular center of mass from hinge point multiplied by angular acceleration. V is equal to r omega, a is equal to r alpha. So when we calculate r, that is a radial distance from center of rotation to that point. And why I'm taking center of mass? Because this is uniformly distributed body. So its center of mass is to be considered to calculate acceleration of entire body. So I can say if any force acts on this rod, that force is going to accelerate it. And that force we assume to be acting on center of mass, or body is going to have acceleration at center of mass. So what is the acceleration at center of mass? Sir, if alpha is known to me, alpha everywhere is same. If body is having alpha, everywhere alpha is same. And acceleration of this entire body at center of mass is this distance into alpha. That means L by 2 into alpha. Okay, done. Newton's second law is, what are the net forces acting on the body? W minus R are the net forces acting on the body. Means, what is the net force acting on the body? It's weight W and reaction induced R. W minus R is equal to Ma. What I want to find out? I want to find out reaction. Okay. W minus Ma. Okay. What is A? Sir, A is nothing but L by 2 into alpha. What is that? If you calculate L by 2, this is 3g by 4. L by 2 multiply here, it comes out to be 3g by 4. So 3g by 4. Now what is this? W minus 3 mg. What is mg? Mg is W. That means W minus 3 W by 4. So W minus 3 W by 4 is W by 4. That means the reaction induced is W by 4. As I told you, these three questions of engineering mechanics you can solve only if your concepts of rotational motion, angular motion, etc. are really good. Believe me, engineering mechanics is a subject which is physics. Many questions come in ISRO, many questions come in GATE, and since this online exam has started, they are going to ask you many questions from engineering mechanics, in fact more than strength of material. That is the reason I'm discussing it with you. Less effort, more marks. I'm very sure 4 to 6 marks might come in your exam. No wonder 6 marks, easy questions, you can score really good. So do it properly and easy questions can be scored. And he's repeating the concept every year. So for the last 20 years when I analyzed, I found he's repeating the same questions. He's repeating the same concepts actually, not difficult questions. And वो भी पता तुम्हें questions कहाँ से उठाते हैं? वो जेई के questions उठाते हैं 11 12 के. जो प्रोफेसर्स है वो जो पेपर बनाएगा, वो अगर आप क्वेश्चन देखो, जेई का पेपर उठा के देख लो, जो गेट में क्वेश्चन आया है या जो इसरो में क्वेश्चन आया 2018 में, वो जेई में क्वेश्चन आया 1990s में. जेई 11th 12th class, friction is there, rotational motion is there. My book, the book which I am referring, I am just going through JEE advanced questions, JEE mains question, that's it. वहीं से क्वेश्चन फ्रेम करता है. फ्रिक्शन, लैडर आपने किया तो है 11th 12th, वहीं से क्वेश्चन आता है, राइट? सो ये आपका एक सिंपल डोमेन है जहां से क्वेश्चन प्रेडिक्ट किया जा सकता है. ओके, डन. नाउ आई गो फॉर नेक्स्ट क्वेश्चन एंड आई एम वेरी श्योर आप ये क्वेश्चन लगा लोगे. आप ये क्वेश्चन अभी भाई लगा लोगे, तो मैं अब आपको ये क्वेश्चन दे रहा हूं. आई एम वेरी श्योर यू गाइज आर गोइंग टू सॉल्व दिस क्वेश्चन. ये मैंने अभी तुम्हें एक रॉड या बार दे दी. लेट मी read this question to you. This is given as 1 meter, this is given as 7 meter. So let me read this question. Uniform cylinder rod 8 meter in length. You know cylinder क्या होता है? SLENDER, पतली. Cylinder, thin, you know. So 8 meter is given as total length as shown and 3 kg is the mass. So uniform cylinder rod 8 meter length, 3 kg mass, rotates in a vertical plane about horizontal axis. Rotates in a vertical plane about horizontal axis. मतलब इस पॉइंट के अबाउट रोटेट करती है. लेट्स कॉल इट O पॉइंट. इसके अबाउट रोटेट करती है. And 1 meter from the end as shown. So this is rotating. This is the instantaneous center. You know, this is the I center for this rod. इसके अबाउट रोटेट कर रही है. Magnitude of angular acceleration of the rod at the position shown. भाई अब इसका अगर कोई एंगुलर एक्सेलेरेशन है अल्फा, तो बताओ वो अल्फा कितना होगा. And you know, this question was fill in the blanks question, so he is not giving you any answer, but it is the free, this is a fill in the blanks question. So you are to find out what is the value of alpha. That is what he is going to ask you. Alpha कितना है, बताओ कैसे निकालेंगे यार, अल्फा कैसे निकालेंगे. Okay, done. Can you tell me where is the weight located? This is the G point. Weight is located here. Weight दिया कितना है, mg. m कितना दिया है, 3 kilogram. This is the weight. Can you tell me how far is this distance from here? Yes, this is 3 meter. So total is 8 meter. G point is 4 meter from one side. So this is the 3 meter. Okay, done. Can you tell me what is the torque? Yes, torque is nothing but W into 3 meter. तो कितना हो गया, 9g. So mg into distance 3 meter. This is the torque. But what is the torque? So torque should be I about O point into alpha. Okay, so what is alpha I want to calculate? 9g over I naught. Okay, g is known to me, but how shall I find I naught? Achha, do you know what is the I of this rod about G point? Yes, ml square by 12. Do you know what is the moment of inertia of this rod about O? Yes sir, parallel axis theorem. Parallel axis theorem. What is that? Ig, moment of inertia about centroidal axis, plus mass into distance between the two axes, that is 3 meter. Okay, so can I say this is now m, L कितना है भाई साहब, 8 square by 12 plus 9m. Okay, what is this coming? m3 है, 3 into 64 by 12 plus 27. Okay, 4, then this is 16. This is how much coming? 43. This value is coming 43. I naught is 43. So 9 into 9.81 divided by 43. That is radian per second square. And let me give you value 2.05. 2.05 radian per second square. Hardly there is any problem in this question now. This question we just now did. इस क्वेश्चन में प्रॉब्लम क्या थी? सेम क्वेश्चन तो हमने किया यार, वही वाला क्वेश्चन हमने किया था. And you know what? I'm going to irritate you with another similar question. I'm going to irritate you with another similar question. And let me give you this question. But yes, don't get much irritated because this question is little different also. Same also and different also, right? Okay, now see this question. He's given a uniform rigid rod of mass m and length L. So there is a uniform rigid rod of mass m and length L, and it is hanging like this. It is hanging like this at one end, and this point is a hinge point. This point is a hinge point about which it is hanging. Now force P is applied at distance 2L by 3. So there is a force which is applied at distance 2L by 3 on this particular rod, something like this, so that this rod swings to the right. देखो पहले जो केस दिए थे उसने वो हॉरिजॉन्टल आपकी बार थी, और बिकॉज ऑफ द वेट एंगुलर मूवमेंट वाज बीइंग प्रोड्यूस्ड, बिकॉज ऑफ द वेट ऑफ द rod, torque was applied and that torque was creating angular acceleration. But in this case now force is applied. Weight is not going to produce any angular acceleration because weight is passing through this particular center of hinge point, center of rotation point. Now this force is going to produce torque. Okay, now question is find the horizontal reaction at the hinge point when this force is applied. Find the basically reaction at the hinge point, and you know what, he has given you the choices also. What are the choices? P0, P by 3, P by 3, 2P by 3. I think these are the choices he has given you. He asked you to find out the reaction. What will be the reaction so that it swings to right? Can you solve this question? Yes. What is the torque? Sir, torque is P into 2L by 3. But what is the torque? I naught into alpha. Can you find out what is the alpha? Yes, sir. Alpha I can find out. Where is the center of mass? this is the center of mass. At what distance? L/2 distance. So everywhere angular acceleration is going to be same. Acha, can you tell me what is I naught? What is the moment of inertia about this point? That we know, ml square by 3. Agree or not? So ml square by 3. So P into 2l by 3, that is the torque applied, is equal to ml square by 3 into alpha. Can you tell me what is alpha? Okay, certain things gets cancel out. Now what is this? Now mass is given as m, so this 3 gets cancelled out. 2p over ml. Let's see, 2p over ml is the value of alpha, that is the angular acceleration. But now I want to find out the acceleration at center of mass. Yes, acceleration at center of mass is L/2 into alpha. Can you tell me that? Now L/2, that is P over m. P over m is the acceleration of the center of mass. Now take the free body diagram of this. Let's say this force is P, reaction we want to find out at hinge point is R, and acceleration of the body is given as A. Newton's second law, P minus R is equal to MA. What is MA? MA is equal to P. So what is R coming? R coming out to be 0. So no reaction is induced, but that question answer could not have been given from the common sense. No reaction is being induced. So reaction at this point is going to be 0. So believe me, the question on this concept have many times been asked. एंगुलर एक्सेलरेशन कैसे निकालना है, उसके ऊपर बहुत क्वेश्चन उसने आपसे पूछा है. So many times this question has been asked from this particular concept. Done. Now let's go and solve the question. Next question I'm going to give you is from the ladder. Now there is a rod of length 1 meter. So this is what is given. There is a rod of length 1 meter and it is sliding in a corner as shown. This side is given 1 meter per second and this angle is 60 degree and this is 1 meter length and this, and let's call it A, let's call it B. You know what is the question? If this angle is given 60 degree, rod is of length 1 meter, velocity at A is 1 meter per second, find the angular velocity. What is the angular velocity of this rod? Answer is 2 radian per second. Second is 1.5 radian per second. Then it is 0.5 radian per second. Then it is 0.75 radian per second. So these are the 4 answers given to us for this particular question, right? This is given to us. Now, how to find it out? I told you, no, that you are to find out now instantaneous center. You are to find out I center. This is the I center for us. So VA is equal to IA into omega. VB is equal to IB into omega. We want to find out omega. So VA over IA. Acha, what is I se leke A tak ka distance? L cos theta. That is the answer. So what is VA? 1 meter per second. What is L cos theta? You know, L is also 1 meter. Cos 60 degrees 1/2. So this comes out to be 2 radian per second. So the velocity, angular velocity of this basically rod could be calculated only if you know what is the basically I center and how it is to be used. In that case, you could have found the I center for this. That is the meaning of this particular part. Okay, now let me ask you this question here. Let me give you this question here now. Let's see whether you answer this question. My next question is a rigid link PQ of length 1 meter. There's a rigid link PQ. One end of that is fixed. Rigid link PQ of 1 meter length is pinned at point P. Pinned point और hinge उसने बना रखा है. उसने P पॉइंट को पिन कर दिया and it rotates about P in a vertical plane with uniform acceleration of 1 radian per second square. So alpha is given as 1 radian per second square. That is the value of alpha given to us. At an instant when angular velocity is given as 1 radian per second, you know, angular velocity is 1 radian per second. So omega is also given, alpha is also given. Magnitude of total acceleration in meter per second square, magnitude of total acceleration in meter per second square of point Q with respect to P. So what is the acceleration of point Q is to be calculated, and answer is given 1.41. Next answer is given 1.73. Next answer is given 2, and next answer is given as 2.83. So he is asking you to calculate acceleration of point Q. Now let me ask you a question. What kind of acceleration do you think will be there? भाई एक तो टेंजेंशियल एक्सेलरेशन आएगा which is equal to r alpha. एक आपका सेंट्रीपिटल रेडियल एक्सेलरेशन आएगा, that will be equal to r omega square. So we know one thing, we have tangential acceleration r alpha, we have radial acceleration r omega square, and resultant of this is r square alpha square, these two r square alpha square plus r square omega raised to power 4 under root. So if you tell me what is r alpha, r is 1 meter, alpha is 1 meter, so this is also equal to 1 basically meter per second square. R omega square, omega is also 1, this is also 1 meter per second square, so this comes out to be root of 2, 1.414 meter per second square. So answer for this question will be something like this. So this is the answer to this particular question. I'm sure you people have calculated this value. This is clear to us. Okay, now similar question, you know, this question is also similar question. I think I should not solve it then. Let me go to next question now. Let me solve next question for you here then. There is a shell which is fired from a cannon. Cannon पता ना तुम्हें क्या होता है? Cannon होता है जहां से गोली बारूद को आप फायर करते हैं. So this is a cannon, right? So a shell is fired from cannon, CANN1. At the instant shell is just about to leave the barrel, its relative velocity to barrel is 3 meter per second. तो अभी क्या है? यहाँ पे 3 मीटर पर सेकेंड उसकी जो वेलोसिटी है बैरल की, सॉरी उसकी कैनन की वेलोसिटी ऑफ शेल, सॉरी, एट द इंस्टेंट शेल इज जस्ट अबाउट टू लीव द बैरल, बैरल से निकलते टाइम ही उसकी वेलोसिटी दे रखी है 3 मीटर पर सेकेंड, whereas the barrel is swinging upward with constant angular velocity 2 radian per second. So 2 radian per second is the angular velocity of this. Magnitude of absolute velocity of shell. What will be the absolute velocity of the shell? The choices given here are 3 meter per second, then 4 meter per second, then 5 meter per second, and then 7 meter per second. So ये हमारे पास 4 choice दे रखी है how to calculate it. Okay, now you know it is having 2 radian per second, and this velocity basically peripheral or tangential velocity will be r omega. This is omega given to us. This is the radial distance at which shell is being fired, and he has given you the basically length of this particular thing as 2 meters. So this is also given as 2 meters. So what is this tangential velocity? R into omega, this comes out to be 4 meter per second. So you know what? This is 3 meter per second and tangential velocity is 4 meter per second. You are to calculate the total velocity, which is 3 square plus 4 square, that is 5 meter per second is the answer to this particular question. So that was the question asked in the exam from here. So that was also pretty simple question. Okay, fine. So that also could have been calculated. Okay, now let me give you this question, whether you can find this question or not. The question is this. Now the question comes is of this ladder only. Let me give you this question. There's a ladder of length. There's a ladder of length L, which is in state of equilibrium. I give you a ladder, and this is of length L. It is in the state of equilibrium, and this angle is theta. Leaning against a wall at angle theta as shown. There's a friction at the surface. There's a friction at surface with coefficient of friction mu, and this side it is frictionless. This side it is frictionless. There is no friction at this side, right? There's no friction this side. Now for the equilibrium, what is the relation between mu and theta? For equilibrium of this ladder, equilibrium means no net force acting on the ladder, no angular velocity of the ladder. For equilibrium, what is the then relation between mu and theta? That is the question. Okay, done. Let's name it A, let's name it B. Friction is there, so F of B will be there. Normal reaction RB, normal reaction RA. FA will not be there, that will be 0. Its weight, let's say W will be here. Weight will act this side, right? Okay, let's say length is L. Make the equilibrium. So RA will be equal to FB. FB is nothing but mu into RB. Done. I think that is a horizontal force balance. Okay. RB is equal to W. RB is equal to W. Why? Because this vertical forces are to be balanced. That means RB is W, so RA is equal to mu into W, right or not? Mu into RB, mu into W. Now take the moment of all forces about point B. Take the moment of all forces about point B and equate it to 0. Let's do that. RA into how much is now this distance? This is L sine theta. This distance is L cos theta. So RA into L sine theta clockwise, and this is balanced by W force into L cos theta by 2. Just check it out whether it is correct. Now this L gets cancelled out. RA is equal to W cot theta by 2. RA is equal to W cot theta by 2. But RA is equal to how much? Mu into W. Okay. W gets cancelled out. So coefficient of friction is cot of theta by 2. Coefficient of friction is cot of theta by 2. And you know what type of question can be framed in exam from here? What type of question can be framed from here is, if he gives you theta to be 45 degree, if he gives you theta to be 45 degree and ask you what should be the minimum coefficient of friction, what should be the minimum coefficient of friction so that this ladder does not slide down or it is in equilibrium, then we can find out cot 45 degree is equal to tan 45 degree. You know, that is the same. So that is equal to 1 and mu will be 0.5. And you know, MSQ multiple select question also you can make, that if there's a ladder only having friction at the base, which of the following true? For the equilibrium, mass of the ladder is not a parameter. Yes, it is not a parameter. Length of the rod is not a parameter. Yes, that is not a parameter. Angle of inclination is not a parameter. No, angle of inclination is a parameter. So you can think of what kind of MSQ question can be framed. What kind of questions can be framed? That is the meaning of it. Okay, I think now this question we have understood. Now let me see what other topics and questions we can cover from this part now. Let me give you some more questions which can be solved now on the basis of this topic. So I'm sure this part is clear to us. Okay, let me give you this question here from the rolling body. There is a rolling body, something like this, right? It is having velocity v, translation velocity, and there is a point a at 30 degree to this. Can you find out the velocity? If this is a rolling body, can you find out the velocity at point A of this rolling body? Now, how to find out velocity of this rolling body here? How do you find the velocity of rolling body at this point here? Now, to find out the velocity of rolling body, what we need to do is this. Number one, at this point, this velocity is going to be v. Peripheral velocity is going to be v. How do we know peripheral velocity is v? Because this is translation. This has to be peripheral velocity also has to be equal to translation for no slip condition, and that is the reason velocity here is v. What do you think is the velocity at this point? Okay, velocity at this point is also v, translation. What do you think is this angle? What do you think is this angle? Okay, if this angle is 30 degree, then this angle is 60 degree. Now what we have to find out is this velocity is v, this velocity is v, this is 60 degree. Can you find out what will be this velocity at point A? So VA is v square plus v square plus 2 into v, 2v square into cos of 60 under root. From where I got this formula? Vector algebra, a square plus b square plus 2ab cos theta. From there I got this particular value. So kitna hota hai cos theta? Cos 60, 1 by 2. That means under root of 3v square. That means root 3v is the velocity at point A. Root of 3v is the velocity at point A. That is what I told you, that this is how velocity can be obtained. So velocity can be obtained at this point, something like this. We can find out the velocity something like this. We can identify the velocity. Okay, now okay, now let me give you next question, which may be related to this only. I'm giving you a rolling body. I'm again giving you a rolling body, and it is moving ahead with velocity v. Now you have to tell me, if I give you a point A, radial distance r by 2, find the velocity at this point. Find the velocity of rolling body at this point, and I'm expecting some kind of fast answers from your side. I'm expecting fast answer from your side. Just calculate it and tell me what is the value of this. How much is the value of this? So what value, what answers do we get for this? Just solve it and tell me what is the value of this. Right now, what is the value here? Translation velocity v, peripheral velocity. Now you know this is v, this is r omega, v is equal to r omega, but translation velocity here is r by 2 omega, that is v by 2. तो यहाँ पे velocity हो जाएगा v plus v by 2. 3v by 2 will be the answer for this velocity at this particular point. So velocity here at A will be 3v by 2. Done? Is this clear to us? Let me tell you, next question is very good question. Next question which I am going to ask you is very good question, and that question is this. Let me give you this question here. Let me add you this question here. There's a sphere which is rolling down an inclined plane. You understand? There is an inclined plane, and there's a sphere which is rolling down an inclined plane. Right? So inclination is given as theta, and there is a spherical body which rolls down an inclined plane of inclination theta. Right? What is acceleration of this? What is the acceleration of this when it reaches the bottom? It starts from rest. It starts from rest and it rolls down the inclined plane of angle theta. What is the acceleration of this when it reaches the bottom? Now you see one thing, he has not given you height, he has not given you length. Let me give you the answers. Answers he has given you is 5 by 7 g sin theta. I told you that engineering mechanics में the question which are framed are actually framed from JEE exam. So ये क्वेश्चन JEE एग्जाम का क्वेश्चन है, और अगर मेरे को पेपर सेट करना हो तो मैं ये देखूंगा कि कहां से भाई JEE एग्जाम का क्वेश्चन मैं उठाऊं, जो अभी तक मैंने उठाया नहीं है। रोलिंग बॉडी में रोलिंग बॉडी है, और जब ये रोल करती है सफियर नीचे पहुंचती है तो इसका एक्सेलेरेशन कितना होगा, दैट इज अ क्वेश्चन। वेरी गुड, दैट इज हाउ वी आर टू कैलकुलेटेड। अच्छा, ये जो सफियर तुम्हें दे रखा है, मेरे को एक बात बताओ, इसका सफियर का मोमेंट ऑफ इनर्शिया कितना होता है? 2/5 mr²। लेट से मास इज m, radius is r, so moment of inertia is 2/5 mr². Agree or not? That is the moment of inertia. Okay, can you tell me the kinetic energy? Can you tell me the kinetic energy presently? Let us say its potential energy is h. Let us say at height its potential energy is, potential energy at this point is mgh. जब यहां पहुंच गया, लेट अस से वेलोसिटी इज v, तो काइनेटिक एनर्जी भाई कौन कौन सी आ गई? हाफ ऑफ आई ओमेगा स्क्वायर प्लस हाफ ऑफ एम वी स्क्वायर। लेकिन सर I is 2/5 mr² omega square plus half of mv square. 2 gets cancelled out. R omega is equal to V. So 1/5 mv square plus 1/2 mv square is equal to 7/10 mv square. अब कंजर्वेशन ऑफ एनर्जी बोलती है कि बॉटम के ऊपर पोटेंशियल एनर्जी 0, यहां तो सारी एनर्जी काइनेटिक एनर्जी है, वहां पे सारी एनर्जी पोटेंशियल एनर्जी थी, तो kinetic energy is equal to potential energy means 7/10 mv square is equal to mgh. m gets cancel out. बॉटम पे वेलोसिटी कितनी हो गई? 10 gh over 7 under root. In exam, one question can be asked about the velocity also. When this sphere comes at the bottom, when this sphere reaches the bottom, what is the velocity at the bottom? You will say velocity at the bottom is 10 gh by 7. But question is not velocity. He is not asked you question about velocity. He asked you question about acceleration. Question about acceleration. Now let us say acceleration is a. यहां पे initial velocity was u. Let us say the distance it covered is l. तो v square minus u square is equal to 2al. Can I say that? V square minus u square is equal to 2al. You'll say, sir, this equation I can use only if a is constant. But a is constant. Why? Because force is constant. कौन सी फोर्स लग रही है इसके ऊपर? वही तो फोर्स लग रही है mg sin थीटा, जो तुम निकालते हो, फ्रिक्शन में कल निकाला तो था। u तो 0 है भाई साहब। एंड व्हाट इज v स्क्वायर? 10 gh over 7 2a into l. And can you tell me now what is sin theta? Sir, sin theta is equal to h over l. h over l. तो अगर मैं इसको मैनिपुलेट करूं थोड़ा सा, तो a is equal to 10g by 7 h over l. 10b by 7 नहीं, ये तो 5 कट हो जाएगा। 5, this is now 5 by 7 into g. h over l is nothing but sin theta. So this will be 5 by 7 g sin theta. And believe me, this is one of the very good question, that if there is a sphere I have kept here and that sphere comes down, inclined slope is theta, what is the velocity of the sphere? What is the acceleration of the sphere? That question can be asked. And if this question is asked, this is going to be very good question. So let's try to understand the meaning of this particular question. Is this clear to us? Okay, now let's next question, which I think I should ask you next question, which I think I should ask you is this question. This is another very, very important question. So let me give you this question also. A 10 kilogram body, there's a 10 kilogram body which is hanging. There's a 10 kilogram body which is hanging at rest from a rope which is wrapped around a cylinder, and the diameter of the cylinder is 0.2 meter. So there is a rope which is wrapped around this cylinder, and उस rope के साथ एक 10 kg की body को मैंने लगा रखा है. Now torque applied about the horizontal axis of the cylinder. What is the torque applied around the horizontal axis of the cylinder? That is the question, and answers I give you, that is 98 Newton meter. Second is 19.6 Newton meter. Third is 196 Newton meter, and fourth is 9.8 Newton meter. So the question is, there is a 10 kg body which is hanging at rest from a rope wrapped around a cylinder 0.2 meter in diameter, and you have to find out torque which is applied about the horizontal axis of cylinder. That is a question which is asked. Okay, done. Now if this is 10 kg body, so 10 into g is the weight which produces some kind of tension. Let's call that tension with force F. Let's call that tension with force F, and let's say this radial distance is r. So can you tell me what is the torque applied? Torque is F into r. That is what we want to find out. F into r is the torque which we want to find out. But you know what, this particular torque, this force which we want to find out, this is also equal to I into alpha. This torque is also equal to I into alpha. Now can you tell me the free body diagram of this? Yes, 10g. And what is this? This is the force. It is not moving, so it is 10g. So what is the torque acting? 10 into g into r. R is 0.1. What is the answer? 10, 10, approximately 100, you know. So 98 looks like close. If we take, no, this is m is 10 kg into g into r is 0.1. R is 0.1. So how much is it coming? 9.8. This comes out to be 9.8. But you know, this question was very simple. But when in exam is going to ask you, alpha. If it is released, what is going to alpha? So if you know the I, alpha of what? Alpha of this. You know, because moment of inertia of this disc, and if it is a pulley is nothing but like a disc only. So if I take a pulley or disc, this is how it is to be calculated. And should I give you the next question? Same question which I was talking you about, that is to find out alpha. So take this question. There's a string which is wound around a rim. So if I give you a rim, something like this, there's a string which is wound around the rim of a flywheel, and the flywheel has a mass 20 kg. That means its mass is given as 20 kg of the flywheel. You know, flywheel is to be treated as the disc only, and radius is given as 20 centimeter for this flywheel, and moment of inertia of this will be mr square by 2, because flywheel is to be treated as a disc only with mass 20 kg and radius as 20 centimeter. Okay, now there's a steady pull applied 25 Newton at one of the ends of the cord. Neglecting friction and mass of the string, you have to find out the acceleration. Alpha of the flywheel. You understand now? So what is the formula? Sir, we have to find out the basically tension which is here. And what is the tension here? 25 Newton. So if I take the free body diagram, 25 Newton, and this is the tension. It is going to be tension here, right? This is the tension value for us. Now this I is equal to mr square by 2. mr square by 2. What is mass? 20 kg, 0.2 square by 2. That means 10 into 0.04. So that comes out to be 0.4 kilogram meter square. That is the moment of inertia. Now this torque is equal to this torque which you are applying. It is equal to F into R is equal to I into alpha. right? So what is F? F is this force. This force is F, which is the tension acting at particular moment, right? And this then alpha can be obtained as Fr over I. So what is F? 25, then 0.2, I is 0.4. So 12.5 radian per second square. That is basically the question which was asked from us. Done. So this is, I think, was a question related to this. Okay, so let me see if we have done some kind of questions here. Okay, let me ask you this question, which is going to be the last question for the day. And the question is good. When a body rolls without slipping, up an inclined plane, listen this question carefully. The body rolls without slipping up an inclined plane. This is how the body is moving. Body rolls without slipping up an inclined plane. There is a roller body which is going up the plane without slipping. Frictional force is choices given are MSQs, directed, up the plane. Frictional force is directed up the plane. Frictional force is 0. Does not depend upon velocity. Does not depend upon velocity. Directed. Does not depend upon velocity. Directed downward. Obviously A and D cannot match. Frictional force is asking you. He's asking you if this is the case, in which direction friction is going to act. Rolling friction I'm going to discuss with you. Okay, now see one thing here. If this body is going up, velocity is this direction. Can you tell me the direction of its acceleration? Why I said like this? Why direction is in this direction? Because mg cos theta, mg sin theta. As this roller is going up, its velocity is increasing or decreasing? If I ask you, its velocity will decrease. Why? Because there is no engine inside. तो अगर velocity decrease हो रही है तो retardation का केस है. Retardation का केस है तो acceleration नीचे की तरफ को लगेगा. Retardation. Why? Because this is the case of retardation. वो आपको इसको MSQ भी बना सकता है कि velocity की direction ऊपर की तरफ, acceleration की direction नीचे की तरफ. And if it is a retardation, acceleration is acting downward, तो I can say omega तो इस तरफ है लेकिन alpha इस तरफ है. See this carefully. Omega angular velocity is clockwise. Omega is clockwise. Angular acceleration is counterclockwise. Velocity upward and acceleration downward. Acceleration downward. You need to understand this way. Acceleration downward. Velocity up the plane. Angular velocity omega. Now you see one thing here. Torque, which is basically going to, the torque which is going to act on the body, which is going to stop it, is produced by frictional force only. Rolling friction I'm going to discuss with you a little later. This is the friction and it produces a torque, and that is a stopping torque, which is frictional force into radial distance. And that torque, because alpha is in this direction, so torque is equal to I into alpha. Don't you think if alpha is counterclockwise, torque is counterclockwise acting, and that counterclockwise torque, there's only one force which is producing that counterclockwise force, or what is stopping the roller? This friction force is only going to stop the roller. And because alpha is counterclockwise, why alpha is counterclockwise? Because acceleration is downward. And if acceleration is downward, why acceleration is downward? Because this is retarding. It is not, velocity is not increasing. So acceleration is downward, alpha is counterclockwise, torque is acting in this direction. So what force is making that stopping torque? Frictional force. So frictional force is going to act in the upward direction. So directed up the plane. It is not zero. Certainly it is not zero, because it is to stop the body, and hence it is not basically the zero term. So this is what actually is the answer for this particular question. Now I think what I will do, I will send you the topics. I will send you the topics which I covered, the theory which I did, and believe me, these 2 days, engineering mechanics, whatever topics we have covered, they are very, very important topics. And as told you, I will be covering engineering mechanics of 2 to 2.5 hour class for 4 days, and that 8 hours will be sufficient for you to fetch 4 to 6 marks. Revise it, don't miss it. Really important questions. And I'm going to send you assignment also of 50 expected questions which are not previously years asked, but they are from JE and all. I will do that analysis here, very important analysis for you, because I have decoded from where the questions normally are asked, because JE से question उठाते हैं इसरो में भी और गेट में भी for engineering mechanics. That is only subject. बाकी कोई भी सब्जेक्ट आपका 11th के साथ मैच नहीं करता, इंजीनियरिंग मैकेनिक्स मैच करता है, जहां से वो क्वेश्चन उठाते हैं. सो आई विल गिव यू दैट असाइनमेंट ऑफ 50 क्वेश्चन ऑन व्हाट्सएप ग्रुप. आई विल सेंड यू, रिवाइज दैट, एंड दीज टॉपिक्स ऑल्सो रिवाइज. प्रेसेस भी मैं भेज ही रहा हूं तुम्हें, सारी प्रेसेस इसकी. सो इसको रिवाइज करो. 4 to 6 marks surely will come for you. And the topics which I'm going to cover, certainly 10 to 15 marks will come directly from there. And similarly, other teachers are also pushing ahead, so that we score more than 50 marks any case in the gate. Fine. Anything you want to ask? Anything you want to tell? Thank you. Thanks a lot. So no counseling here. No counseling here. Okay. No counseling here. Only you can call me later on. But yes, anything related to this class if you want to ask. Okay, thanks a lot. Then I think I will continue class tomorrow. But tomorrow my class will be at 2 o'clock. So live class will be at 2 o'clock. I will wait for you. Come there. We'll enjoy. We'll have good topics tomorrow, and I'll try to cover majority of the topics. Thank you.